build in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? How's it going? Let me turn the music on. Let's get the music on. 45 stream streak. Let's go, dude. Nice. Yeah. Let's see. Let me get TikTok audio fixed. I see the sound settings are really low. I wonder why that is. Device properties. Maybe let's put this a little bit. Let's put the 70. Cool. Let me boost the levels on this. Okay, that looks a little bit better at least. Fuck it, make it 500. Okay, cool. Zigzag, what's going on, dog? What's up, my guy? How's it crack-a-lackin', dude? Dun, 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 dun. You got a 101 on your chem test? That's dope, dude.
That's dope.
Alright, let me start the event on Discord. My bad. Neglecting Discord while I get all the... Oh, they changed all the overlays on this. Oh, this looks so different. What did they do to this? What did they do to my Discord? Why did they change things? What's up, Swaz?
Did you change my name from Quandre to Swaz?
I don't think I did. But I know your name is Swaz.
That's weird.
Did your
Like
name
switch for some reason.
Has your name always been Quandary, or like what's up? That's a quandary in itself.
Oh no, that's my burner Instagram account, so I just like put it as my name for this.
Bro, what? You have a Finsta? You're too young to have a Finsta, dude. What?
A Finsta? What's a Finsta?
Fake Insta, Finsta, fake Insta. Y'all never heard of fake Insta before?
Oh no, it's just so we can clown on like the other schools we play in basketball.
Oh, I see. Like talk shit without getting hit. Is that kind of what it is?
Yeah, pretty much. Yeah. Throwing shade without getting shade thrown back, pretty much.
Why eyes so big? Coke? Why my eyes are so big? Y'all gotta chill. What? One sec. My microphone stand just decided to fall for the first time in probably 3 years. Okay, there we go. That's better. I think I've ever had that fall. Okay. Alright. Nice. Okay, that's working. Good. Cool. Awesome. Y'all tell me on TikTok if things sound okay. I hope they do. I've been experimenting with different audio levels, and I'm running 2 different PCs streaming this. So that second PC is in charge of that one. So we'll see. What's up, Swaz? You got a test coming up? You just coming to say hi?
Actually, I got a take-home test, and since I have like a 75 in that class, I thought this was a great opportunity to boost it.
That is a great opportunity for us to help you out. For sure it is. That is true.
Good job.
All right, nice. Well, okay. Post some of that stuff in the, you know where to post it, and we'll go over it.
Yes, sir. I'm getting on it as we speak.
Oh, I really don't like what they did with this. I hate these overlays. What is this overlay shit in Discord, dude? No. I can't, like, see half of my fucking channels now. Discord. There they go. Trying to make something fancy. They end up messing it up. So I think I can, like, disable this, maybe? No, that doesn't do it. Fuck. Okay, whatever. Ooh, we got a lot of screenshots for today. Shantrix, Adarsh, Seth, Equity, Swaz, Equity. Y'all just dumping a bunch of stuff today. Okay, we got a lot of questions today. That's fun. Okay. Yeah, they changed the UI of Discord. I don't know if I'm the biggest fan of it. I don't really like what they did to it. It looks too much like... I don't know. Like the mobile. I hate the mobile Discord. I'm not the biggest fan of it at all. And Felicia with a question. 4.16. Okay, cool. Well, thanks for coming by and everyone's submitting questions today. We got a lot to go through, so...
They're Etrity and more Etrity ones and more Swaz questions.
Yeah, there's lots of them. Okay, well, let's start the stream off because I want to be able to go to the gym today. Otherwise, I won't be able to. All right, let's do it. 3, 2, 1. Go. Welcome to Office Hours. My name is Dr. Gold. This is Actual Education, the stream that helps you out with math, homework, science, homework. All sorts of fun stuff. If you're joining us from TikTok, Twitch, YouTube, welcome. This is the stream where we help you out with your math and science questions or homework or, you know, test reviews or, in Swaz's case, a mock take-home test. That's what we'll call it, Swaz, okay? We're going to call it a mock take-home test.
No, it's real, man. It's real.
I'm not technically not allowed to, like, do your take-home test for you, but...
I won't say none.
We'll say it's a mock take-home test, but okay. All right. Let's see.
Shantrix is first up, I believe.
Yeah, Shantrix is, but Shantrix is also that's question 25. That scares me. Shantrix, when you send me these, send me the solutions,
I have
so I can see approximately how much time that's going to take.
I do have a tactic on it, so.
Okay, that's cool. Let me see what Felicia has a question too on 4.16.
I am that Dosti. I am that Dosti is the other one from yesterday. So.
Yeah. I know.
And they are first up on Data based on our
4.16. Based on problem 15. Team. Okay, so question, Felicia, with your question, your 4.16 that you asked, it refers to another problem. Oh, does that refer to the one beforehand? Is that what it's doing?
Mm-hmm. Yep. He's referring to the one, yeah.
Referring to this. What class is this in again? Didn't we answer one of Felicia's questions earlier, didn't we? Oh, probabilities? Probability mass function. Oh, that's a fun one. Oh, it is probability. Happy pot. Okay, cool. One second. I want to see how bad this number 25 is. That's fucking gross. Bro, do you see how long this fucking solution is? I'm gonna veto that. That's not gonna be done in time. I don't care. I don't care what your tactic is. If your tactic isn't less than 3 fucking pages, it's I don't care.
Well, 1 page of notes. That's only the first part.
That's a lot of stuff, Shantrix. Jesus, go find me something easier, please.
Yeah. That one.
Yeah. I don't need to like self-flagellate myself live on stream. You have the answer to 4.15. The tactic is to copy and paste the solution.
Good job.
Yes. Oh, what is Shantritz's post now?
Okay,
So you know.
I'm gonna do Felicia's. I want to do Felicia's
With
first.
the Shantritz's one, so you know what I've done.
All right, let's see. In problem 15, let team number 1 be the team with the worst record. Let team number 2 be the team with the second worst record, and so on. Let YI be the team that gets the draft pick YI. Okay, cool. Thus, y1 equals 3 if the first ball chosen if the first ball chosen belongs to ball. Okay. Here we go. NBA draft. This is kind of relevant. Are we in the NBA like Final Four or something right now?
And 15 solution is in Discord for you.
Thank you. Awesome. Thanks for the follow. Tutoring with Ernest. What's up, Tutoring with Ernest? Are you a tutorer? Do you tutor?
Ernest, really?
Ernest is one of my good friends from actually middle school. I was at his wedding. I wore a wedding dress for it. It was pretty funny. Okay, and then they have the answer to 15 here. All right, let's see it. Posted a new one. That's better. Thank you, Shantrix. Yeah. Yeah, don't give me questions that are that long. You mean well, but like I'm never going to do those. Yeah.
That's not today's work anymore.
Okay,
That's
let's
going to
see.
be tomorrow's.
This is 15. I just need to see what this question's about. 11 teams that had the worst one-loss Okay. Okay. A total of 66 balls are placed in an urn. Why an urn? Isn't that like a thing for like ashes and stuff, dude? When people die. Each of these balls is inscribed with the name of the team. 11 have the name of the team with the worst record. 10 have that. Okay, cool. And so on. One ball having with the 11th worst record. Okay. So this is actually kind of cool. It's almost like a factorial type thing. So we're saying like worst team has 11, and then like the 11th worst team, that's gonna be has 1 ball. Okay, and then it just keeps going down. So 10. This is like the second worst. I guess this is the first worst. First worst sounds funny. Okay, and then it goes down. Ding 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 ding. Okay. A ball is then chosen at random, and the team whose name is on the ball is given the first pick in the draft of players about to enter the league. Another ball is chosen, and if it belongs to a team different from the one that received the first round pick, then that team gets the second pick, and so forth. Okay, but what was the question on 15? What was 15 even asking?
Find the probability mass function of x.
Oh, no, wait, sorry, there's more to it. No, sorry. There's more to 50. Damn, dude. Why is your teacher giving you such lengthy ass questions? There's so many words on this. I think most of the students I work with today would have stopped after like the second one. I don't think they would have read this far. This is a lot of stuff. Why are they playing? Yeah, exactly. That's where you put ashes, dog, right? That's what I think. Okay. If the ball belongs to the team receiving the first pick, then it is discarded. Okay, so they basically kind of do it with replacement or without replacement, whatever. Finally, another ball is chosen, and the team named on the ball, provided that it is different from the previous two teams, receives the third draft pick. The remaining draft picks 4 through 11 are then awarded to the 8 teams that did not win the lottery in inverse order of their one-lost record. Okay, so only the first 4 teams... So only the first 3 teams, actually get a lottery. And then the ones after that are just sorted by their win-loss order. Okay. Let X denote the draft pick of the team with the worst record. Find the probability mass function of X. Okay, so since the team with the worst record is either one of the 3 lottery picks, that's cool, right? Yeah, so either they get one of the 3 lottery, or if they don't get the 3 lottery, they have to be the first one out of the rest of the picks. What's up, Jabron? You found us, dude. Congrats. You found us twice. Okay. X takes the value 1, 2, 3, 4, and X equals 0 for all other values of X. Right, okay. So the probability that they're the first round pick is 11 out of 66. Okay, cool. The probability that they're the second pick. Oh, wow. So that's given that another team is chosen first. Times the probability that team I is chosen first. So, yeah, 11 over 66 minus... Oh, man, this is getting complicated. Why?
Yep.
Why?
You enjoyed that?
This is
that's
pain, dude.
annoying.
This is fucking pain. Oh, my God, dude. What? Really?
Do we need to step this one? Do we need to trash this one out, too?
I don't want to trash this one as well. Because...
Yeah.
It's not. It's at least a short solution. It's just difficult. I have an exam April 3rd.
We're in 16. We don't care about this one.
Yeah.
This one's just the answer. The helper. They did a 16 instructions.
I just don't understand why life has to be so difficult for some of these kids. This is ridiculous, but okay, whatever. Okay. So the summation thing is interesting here.
The 16 is 3 parts. If that helps you.
Well, maybe I'll do one of the parts. I'm just trying to understand the solution to 15. I'm trying to understand the solution to the one before it first. The one that we need for it. Okay. So the probability that the worst pick team is the second pick. Sorry, the worst team gets the second draft pick is going to be the probability that someone else is chosen before them. So Team I is chosen first. Okay. Well, no. It's the probability that they're the second one given that Team I was chosen first times the probability of Team I being chosen first. This looks like some like conditional probability. Probably that Team I is chosen first. Bro got a week, yeah. That's the law of total probability? The law of total probability is that... Sorry, what do you mean by the what do you mean that's the law of total probability? Sorry, Endar. Probability of B is equal to the probability of B over A1 times probability of A1 plus the probability of B over A2 times A2. Bro's gonna lock in trust. I have never seen this before, and I've taught a lot of statistics and probability, but I've never seen this. Let it be required to determine the probability of event A, which can occur with one of the events forming is this. Probability of A is the probability of HI times the probability of A given HI. Oh, okay. They're doing all the different cases. This is kind of like Bayesian probability, isn't it? Yeah. Okay, I think I'm starting to get it. Where's my thing? There we go. Okay, so yeah, you use it in Bayes' theorem, right? Yeah, that's what I thought. Okay. So the probability of them being second given Team I is chosen first times probability Team I is chosen first. The probability of Team I being chosen first, right? Yeah, is 12 minus I over 66. So if they're the first team, they have an 11 over 66 chance. If they're a second team, and we're only going... Wait, we're only going to given... Why are we starting at I equals 2, though?
Because we're understanding probability of S equals 2.
Oh, well...
And then the third droves.
No, I get it. The reason why we're starting at 2 is because if we started at 1, 12 minus 1 is 11. 11 over 66 is the probability of the worst team getting picked, which we don't want that. There's a 10 out of 11 chance the Lost Boys don't get picked and a 1 over 10 chance they get picked second. Yeah.
What's the third? What's that number 3?
The Lost... What are we calling the Lost Boys like the worst team? Is that what we're saying? Okay. I get this. And then this conditional probability kind of messes with me, though. Thanks for offering to take my exam for me. Ha! No. Bro, you don't want me to take your exam. If this is your exam, you don't want me to take your exam. Let me just see how this works.
I understand that.
Don't worry, it's going to be harder. What type of sadistic class are you in, dog?
It's
You gotta check.
minus the first.
I get
Or
this.
team I.
So this is 11 minus so the reason why it's 66 minus 12 minus I, because these are the number of entries that get excluded, I guess. So for instance, if the team with 10 entries got picked first, then you suddenly have like you have 10 less things to worry about in the lottery. Okay. All right, whatever. This
In
comes
the
out to
third
being
one,
this.
Chris.
This comes out to being this. Okay, let's see how that does. That's yeah, okay, that's 1/6. I guess whatever, that's 54. Okay, cool. All right. Great. This is really mean. Yeah, each team has a different chance. Yeah, that's the issue. Right, because you have to do the luckily we stop after the first 3 teams. If this
14, friend.
no, the first 3.
And the fourth one is a finally taste.
No. Well, picks 4 through 11 are no
Based on the
longer a
question,
lottery.
It says it's solutionized in the first 4.
No, it's the first 3. It's 1, 2, 3.
And then there's a fourth at the end of that. Final the fourth.
Oh, well, that's just the probability of them not getting picked 1 through 3. Yeah, that's easy. No, because they're the worst team. If they don't get picked on the first 3, Seth, they have to be the 4th. That's where this comes from. This is a weird question. It's cool. I'll give you that it's cool, but man, this is a pain. Because look at this, probability.
It's a double summation.
It's a double summation, and then you can't have j equal to I, because now you have to exclude 2 teams that have gotten picked. So the probability of you being 3rd, given that all the other things were picked first, but what about chosen 2nd? Yeah, wait. That's my question. How do they go from here to here? I believe this is wrong. If Team 11 gets picked, do 10 of its balls stay in the jar?
No, it draws and tells.
Well, no, they do. They do stay in the jar, but they're not counted as valid, like, things in the next drawing, is what they're saying. Because that's what they say here, is that, if it belongs to a team different,
then it goes through.
if it's not different, they just draw again, is what they do. So effectively, walking stick, you are right. Effectively, they're not there, which is why this term goes away. That's why they like subtract it from the pot. This step here boggles me real quick. So probability of X being 3 given Team I was chosen first, but it's not just Team I being chosen first. It's Team I being chosen first, Team J being chosen second, and then also J being chosen second given that I was chosen first.
Which is the next step. The first step is the probability.
This is okay. This one's all right. This one we understand is the same as this.
And then they open the bracket and put the stuff into the first case.
But dude, this is where this boggles me, dude, bro. How do you calculate this without like running this through code? I can understand maybe how to do this. Well, no, not really. This needs a calculator for sure. Unless you're gonna write out 9 different terms.
10
terms. And then this is even weirder, right? Because you have to do it where J does not equal I. Yeah, no, dude, you're cooked, dude.
But the problem for today, the person once done has 3 parts, where each part starts on the first.
Yeah. Well, let's see. HappyPot says, J can't equal I because you can't have the first and the second one being the same. That's why this exists. Okay. I will attempt to like make some sense of your next question, but may not be able to.
Let Team 1.
Let Team 1 be the team with the worst record. Team 2 be the
Number
second
2
worst
be the team with
record.
the second worst record, and so
Okay.
on. Let YI denote the team the dot. That's draft pick number I. Thus, yi is 3. If the first ball does belongs to team number 3, find the probability mass function of y1, y2, and y3.
Okay.
Or conversely, wished.
Wished. Find the probability mass function of X. Why I determine the team that gets picked. Draft number I. Oh, so y1 equals 3 means the third team got picked first? Oh, okay.
Yes. So find the first, second, and third.
So
Y1 means first pick, not
first pick. And
not
then
team number.
you want it, this is y1 of X though, right?
Well, yeah, mass function of the following.
Oh, okay. Oh, man. Well, we did all this work just to find out what P1 of... Well, let me think, sorry.
No, P of X was. This is the probability function of X.
Sorry, why I...
And now it's
Draft number 1. Oh, okay. Oh, okay. This is not bad. Y1 is not bad, because you're just asking who gets the first draft pick, right?
what? No, I know
Yeah,
who it
yeah.
is. It's anybody.
Yeah.
It's somebody.
Y1 is fine. Because, for instance, so Y1 of... And sorry, X refers to... 1 is the team with the worst record. So Y1 of 1 is equal to 11 over 66. Right? That's the probability of them, because they have 11 balls and there's 66 total. Y1 of 2.
Is this tensity sets?
Good, very good. Exactly. Yeah, this is all right. This
So
is
it's a summation of y.
what's up, Rex?
So it's a summation of 11 sets plus 10 sets plus 9, etc.
Yeah. Okay.
Where the top it says
Dot.
11 summation
Exactly. Yeah.
from 11 to 0.
And then eventually this goes to what? Y of 11 is equal to 1 over 66.
Yeah,
Yeah.
so it's 11.
Okay.
It's 11 plus the summation. It's the summation 1 to 11.
Uh-huh. Okay, that's Y1. We did one part of this question. Yeah.
Not done though.
Yeah, this is about to get nightmare hard for Y2 though.
I do number 1 though.
Sorry for what?
You don't have the answer though for first part.
Oh, I do. Isn't it just this?
It
This is
wants
just
a. It wants a mass function. That's not a function.
Oh, it wants a function. Oh. Is that like a PDF? Is that like a probability distribution function?
A function defines for any x value. It's going to give you a solution.
I agree
which is
with
a summation
Endar.
problem.
It's
exactly
12 minus
Maybe.
I over 66. Doesn't this have
There's
to
a
also
function.
normalize though? This has to normalize to 1 though. And it does. Yeah. It's a simple triangle. Yeah. Yeah, it just looks like this, right? PMF is like a PDF just for discrete. Ah, okay. So yeah, okay, I got you, because this is not continuous. Interesting. All right, I learned something cool today.
So the answer is not the constant material. It's actually a function machine.
Well, yeah. This is not this is describing the function, and then this is what it actually is. So
In terms of
that's Y1 of I believe is what it is. Sorry, that's Y1 of I.
no.
Well, they wanted it as a
Y-
function of X. So it really should have been this.
It doesn't say. No, it doesn't say it's y of x. Oh,
Yeah, it
I
says
just said
find.
That's,
It says find the
okay.
probability function of X.
no, it's not. That's number. That's 15.
Oh.
Read number 16. It doesn't say. I just said estimate.
Oh, all right, whatever. We're just gonna call it X.
I like x.
I like X. Okay. The second draft pick is not so intuitive though. No?
The second draft pick is the summation function below that we said on problem 15 in terms of everybody.
Uh-huh.
It's that second function in terms of everybody.
So Seth, you think it's this? Is it?
No,
Oh,
that's
no.
the wrong problem. That's I don't care about number 3 right now.
What about this? You think it's this one? Is it?
It's as if it was, because we said here's how I'm. getting at. I am, I'm a senior. I probably won't know what I'm doing, but
I know, Seth.
based on
I
what
think you're right. I think it's this, right? Because this is the probability of you being chosen second, right? But we need to modify this.
That's the probability of chosen second for not specified team though.
Correct. This is for the worst team. This is for the worst team.
Which we don't care about the worst. Do it.
Good.
Any team.
Correct. I agree with that.
They be taste for everybody.
So, this, I believe what we want to do here is we want to replace this 11 with 12 minus x. And I think we want to replace this also with... No, I think we want to leave that.
No, you do have a beep now because now you have I and at in place in the same thing. Doing that would give you a multivariable problem, which is bad.
Oh.
You
But this is
can't
a
have-
summation, right? Is this okay?
Yeah, but it's a multivariable, which means the at is not going to get deleted with summation. It's indexing an I, not an at.
Sure. But then you plug in x and you'd get a number.
Yes, Jeff.
Jeff says the x can't get deleted. Maybe I'm not understanding.
Yes, that's okay. So we're good.
You might need to sum over all but x. That's true. Yeah. So it's like it's this with it's this, but you're not allowed. Am I gonna do this like not equal to x?
Yeah. Hope not. That'd be annoying.
Right? I feel like that's what you have to do though.
Solve it. We're just asked to find a function for the case.
Oh my god.
We're just asked for the function case, not the. Yes.
Yeah,
Jeff,
okay.
not equal-
So
first
it's
thing.
something like this. Okay. All right,
and a half,
and then
it's an
it's gonna get magnanimously harder for Y3, and in the interest of time
Yep.
and just helping other students, I'm not gonna do that. So happy
Yeah,
at least.
Remember, you actually an hour. We did an
Yeah,
hour.
yeah,
Okay,
yeah.
so I think
Okay,
we're
so
done
happy.
So
So we at
let's
least
go on to-
we did Y1.
Let me put Chambers on top. You know why?
Yeah.
His problem is also probability. So
Okay, I like that. Let's do that.
in
let's
the
do-
interest of what we're doing.
Yeah.
This is also probability. Is probably we can probably get.
Going to be the probability of losing by probability of winning. Yeah, you could
Now,
probably
here's
do
the annoying-
the inverse.
Here's the annoying. It's number 24.
Well, that's okay.
So,
I get scared by number 25 questions. Number 25 are just
He
nightmares,
has
bro.
a okay at it, but finding the L value is annoying.
Like the fact that this this
my
is
tactic
the
was-
solution. This is the solution to that
'cause
number
my tactic
25.
For the first case, I wasn't even dealing. I didn't have a. I don't have a tactic for solving
You're welcome, happy
for
boy.
for T to 337.
Okay, let's
Is
do
get
more
a
probability.
spreadsheet, the numbers in and
More
and
pain
then
and
knock them
probability
out.
today. Let's do it. All right.
Knock them
Good
out.
job, Felicia,
I
though, on your question though. I liked understanding your question, and then I liked understanding why I don't want to do it. So. Okay.
Okay.
Bro-
Tarina
bro-
is a tournament in which no game can end in a tie.
No game can end in a tie. Wow.
He continues
No
to play
participation
games
trophies.
Until he loses 2 games. He continues to play games until he loses 2 games, at which point he's eliminated and plays no more games. The probability of Tarina winning the first game is 1/2. After she wins a game, the probability of Tarina winning the next game is 3/4.
Mm-hmm.
After he loses the game, the probability of Tarina winning the next game is 1/3. The
I think I wanna
probability
make a
that
tree.
Tarina wins 3 games before being eliminated from the tournament equals A over B, where the function A over B is in lowest terms. What is A plus B?
Oh, that's cool.
Now, so I see 2 cases here. Already.
Well,
Let's see,
let me read
wait,
it. Let me read it first because I didn't
Basic.
really get that. Karina,
You write this-
she
you wanna
continues to play until she loses 2 games, and then
who's
she's
Felicia?
eliminated.
I don't know. We don't have Felicia in this game.
No, Karina. I said Karina, right?
Sorry. Okay, sorry. 'Cause,
Okay.
I see
You're
this in
okay.
2 takes. A, there are no losses. B, there's 1 loss.
Well, yeah.
That's the case. I see.
So first game, right? She can either win or she can lose. Yeah. I like building
Yeah.
a common tactic, guys. When you're doing these types of probability questions, is to draw a tree. I think
But
it's
you
called a
cannot lose more
decision
than
tree.
one. You cannot lose more than once, though.
Yeah.
As soon as we lose a second, we lose.
Yeah, that's
And
okay.
it's
So that's the first game.
impossible. In the second game, based on first either direction,
Okay.
no Jeff. Otherwise, she fails. If it's on the third game, she fails.
Yeah, okay.
Third.
One sec.
The
The
fourth
probability
game can
of
be
her
a
winning the
losing
first
one.
game. Here we
Care
go.
about
Probability of
that
winning the
fast.
first game is 1/2.
Well, the winning the first game is 1/2, yeah.
Okay.
And losing is the half.
After she wins the game, the probability of
be a
her
half.
winning the next game
So, yeah, we do
is
that fourths.
is
The win
3/4.
case,
Okay, that's cool.
And then the
So that means
losing
this
case-
must be 1/4, right? And that must mean
Well,
this
we're
is
not
1/2.
there yet. We're only rounds, aren't we?
Yeah. So the probability of something happens is 1. So anytime you get the probability that wins, you do 1 minus to find the probability that she loses.
Well, I know the second game. I know the second game on a lose category.
What do you know
the
about-
second game on a category as well.
Well, let's see it. One sec.
Based on the
After
next
she
one.
loses a game, the probability of winning the next game is 1/3. Okay, so this is 1/3,
So yeah, 1/3 and 1 2/3.
and then lose is equal to 2/3. Okay,
And
cool.
failure.
I think I'm starting to get this.
That's failure. So we can't have another.
The probability that
that's-
Karina wins 3 games, she wins 3 games before being eliminated.
Okay, so here's a note. So if we go down to the bottom, your fourth direction, your fourth case on your case tree, it's a failure.
Yeah.
The fourth case. So lose, lose, fail.
This is
Can't do
failure.
anything.
This is fail. Yeah, you
That's
messed
2.
up. This is fail.
You can have that, but we don't want that. So that's a
Can't do
no.
that. Okay.
Now, if we win any of the other conditions, we can do a third game.
So we can do this, right? So we can do this. We can do another game. So what do we say after she loses? After she wins a game, her probability is 3/4 and 1/4, right?
Yep.
So after she wins this one, this is 3/4
No, win-
and then lose 1/4, right?
and then failure. So we can't have that. That bottom case is that third case. is bottom case.
This is you're right. Lose, win, lose is also a failure. Uh-oh.
You done messed up, Aaron!
There's only one direction this tree is gonna go, I think.
Okay,
Now,
this is
win, lose, win game. That's it. We can't stop
Oh, wait,
there
but-
though. That's 3 games.
she
need one more.
wins. She wins. Wait.
3 games.
She has to win 3 games before being eliminated.
Before we go on though, it's not the one yet. We need to finish out third name cases.
Not a failure as long as you try.
We need to finish out third name cases.
Yeah. Let's do this one. Sorry. So this was the
After
second
4
game.
She can't have
Yeah.
done 5 games worth of
Let
stuff.
me get the third game case real quick.
Yeah.
So then we have
Be-
this is the third game.
Yeah, the other
So-
case. Yeah, it's gonna be a hairy tree.
This is a
So
very
win
messy
again.
tree. I should have made these different colors.
Yep. Oh, you can't have 2 wins cases. That's not valid.
Sorry.
Win-win.
You can't just. It's not a win-win. Oh no. Okay. Win. Lose is equal to 1/4.
Yep.
And then this is
a
lose,
failure.
but after they lose, it's 1/3 and 2/3.
And a win. Yeah, winning is a third, and then losing is a 2/3. But also, we don't want that option.
But also
And if they-
win, lose is also
lose,
fail.
capital fail.
Yeah, this is also a fail. Uh-oh.
You have to move your tree around because that win condition is about to have to split off again.
Okay. So let's say we've gotten to 3 games so far, and I'm gonna start using different
We only
colors
have
for the next one.
condition since we've succeeded so far.
The probability that
first-
she
the
wins
first case is
3
now
games. Oh, she wins 3 games before being eliminated. So
done.
this would be it. She wins, right?
Yeah, that's case A. Because there's
Cool. So this is
also
win, right?
lose-
This is win, right?
Yep.
We're cool with that.
No, it's not a win, but it's a success in our conditions.
Yeah. We're gonna call it like she passes. Nice.
Yeah. Because we can't. Because she could lose.
Okay.
The next be done. But
So
we don't care.
win,
Get there.
lose. Now can have win and lose after it, right?
But if it loses again, we have a. Remember that one below there too. The win 1/3 on the third game, you can still split again.
Yeah. Okay. Lose. Damn.
Yes,
This is quite.
secrets. That's what we have here. That's what we're going to be having.
Okay.
Win,
So
lose,
win, lose,
The
lose.
bottom
This is also a
is
fail. This is a dead end, right?
Yes, that's. Two
But this
fails.
is a pass
One
on
is
the
a-
top.
We've ended right there.
Nice.
And then we have the last case. We still have one more case to tie.
Right here, this one.
Lose, win. What happens? Because you have to. No, it's not that one. Not that one. I was referring to the one above it. Win, lose, win.
Oh, sorry. This little
We
sneaky.
still have that little
Sneaky one.
to finish off.
This one's sneaky.
I said you have to move your tree because it's
All
already
right.
it's
Yeah, I know.
It's a split.
Okay. So after winning, it's 3/4 and quarter.
Win again or lose and take off the tree.
So
Right there.
win is
Win
3/4,
at 3/4, and tree ends right there at the lose. In
Lose.
either condition.
1/4.
And the lose case is too many loses. That's a fail, and the win is too many wins. So we've had a success there.
So this is a success. Cool.
And
But then
we
what
have
about this
we
one?
have lose,
We have this
win,
one, right? Lose, win, win.
then
And
what
she's
happens?
good. Isn't she good here? No, she has to
Yeah.
win 3. She has to win 3 though, right?
We have to complete the 3. We have to go out to 4 games.
Okay.
Or
Okay.
the-
Here we go. All right. So then we could have.
There's only one way so far that wins in 3 games. That is that 3 games is enough.
Oh my god. All right. This is win.
3/4.
Win 3/4. Lose equals 1/4. And then this one's a
yeah,
fail,
both
but this
cases.
one's a success.
Yeah, both cases end. So we have 4 cases we need to include, and the rest of them we still need all the cases that.
Oh my god. This is the biggest tree mess I've seen. But okay.
Now we need a probability of each case. Now we need
Oh, okay.
All
All right. But we just need the green cases, right?
No. The probability that is.
Yeah, she wins 3 games before being
Yeah, but
eliminated.
what about the ones that he doesn't? We still have to remember that those are still on the bottom. Lose 3 games. Is A over B? Where A bigger than those terms.
Wait. Don't I just add up all the probabilities of her winning?
In each respective taste,
Yeah.
and take the taste. Yeah. So the next thing I'm gonna have is write this in blue if you want to for each taste.
I'm gonna say this one. This is one, right? Yeah.
Next step I'm gonna say is
So that's
is write action probability for each taste. It's not a full taste. It's just each taste.
sorry. I'm just trying to
Have
understand.
that.
Why do I need to calculate the probabilities of her failing?
Because those can't be probabilities for winning.
Okay. So, can I just do 1 minus the probability of her failing?
Yes. That's why I'm doing it. That's a checker. So we have
Okay.
a checker.
So-
Go ahead. Write the taste for write the probability of each taste.
Well, I don't want to do all of them. I want to do like the ones I need to.
Well,
Which-
read all of them if you want to.
Do we need all of them? I think we only need one. We either need all the passes or all the fails, right?
If we get both, we can make sure we're right.
Oh, I don't want to make sure I'm right. I just want to be right once. That's okay. Again, in the interest of time, Seth, I don't care about checking if I'm right because we know if we're right or wrong. I just want to know if I got the right answer.
How do you know if you're right then?
Because we have the answers.
How do you know you have the answers?
Because Shantrix gave them to me, didn't he? Yeah. Or I think he did. Shantrix, do you have the answers to this one?
How do you know?
Well, I'm hoping he does. Because if he doesn't, then I'm.
If
Then
he
I'm
doesn't,
going
you
to
know,
the
said
next.
it.
Well, if
Yeah,
he
but-
doesn't, I'm going to the next question. You need all the possible ways for passing, and for that you'll
that
need to
you'll need-
account. Yeah, he has the solutions. We have them.
We are. We're not worried about those. We're worried about our pass tree.
Yeah, I'm just doing the pass tree. Okay.
The probability of the first case is 1/2 times 3/4 and 3/4 plus 1/2 3/4 and 1/4.
Yeah, you just need to add the passes. That's what I thought.
And I'm just saying you can also check all the fails and know.
I'm not going to check all the fails. That would take too much time.
Well, it's just that equals 1 minus the fails, and then multiply everything.
That's another one. So we have
1/2, 1/4, 1/3, 3/4.
yes, I like that. And then we have
1/2, 1/3, 3/4, 3/4.
no. I agree. Seth is right as well, Jeff. I know it's the redundancy. Yeah, if I had all the time in the world and people were paying me for it, I would do it, but I don't. 1/2, 1/3, 3/4, 3/4. Yeah, cool. We're good with that so far. So
Yeah,
it's like
and
some
you have to add
massive
those.
like LGBTQ flag of like questions or
You
something.
have to add those.
I do. So this is gonna be 9 over 32. By the way, you're using the law of total probability. Oh, you're right. You're right. You are right, Endar. I am technically. Okay, this is 9 over 32 plus 3 over 16, 48 over
Well, you can simplify
96.
that before you do it. Before you do that, simplify the 3's cancel.
Oh, I'm just gonna leave them all. I'll deal with it later.
You're gonna be nice enough to add them all up and simplify the entire debt. You have to
I
test
don't.
at the
I
end.
just don't want to. 48.
It's kind of A plus B, where A and B are the lowest terms. So
48.96 and then plus 9 over 16. Oh, well, all these are kind of like 96, which is nice, right? So I just need to boost this one to 96. Right? 2443s on all of these? Yeah, 2443, 2443. This is
that's
244.
nice.
Yeah, that's actually kind of nice. Okay. So it's 27 plus 6 plus 9 all over 96. So that's 33. So that's 42 over
Which
96. Which simplifies to
That's gonna be
21
wrong,
over
right.
48, which simplifies to 7 over 16. Yeah?
Which is not correct yet. You're not done yet.
Well, 7 plus 16 then, because we want the value of A plus B. 7 plus 16 is equal to 23.
Is that it, Sandra?
That's it? Yeah, we did it. Nice.
Obviously don't.
Yes, good job. Love it.
Alright, that's better than the other one.
Wow.
Questions and then you enter the squad.
Okay.
Oh, and I'm the dose to be where we're gonna get that one, because that one's an old one.
All right, give me a second. Let me just recollect my thoughts after that. Went through 2 nightmare probability questions. Oh my god. Seth, I love how you,
No.
I love how Seth put an X on Shantrik's first question. He's just like, no. I agree with you, Seth, by the way. I would put
So
a big,
that's a
big
Adarsh,
fat
and
X
I'm
on
that
that. Adarsh is next, yeah. What's up, Adarsh?
Yep, and then I'm that dose because that was an old lesson we need to clear.
Yeah, you're right, Shantrix. That wasn't a nightmare. I mean, it wasn't a nightmare, but
You want to do
It
the
was-
other one?
it was a lot of writing.
Yeah, if you want to do the other one.
this was a lot of stuff I had to write, dude. I had to write a lot of stuff.
We didn't have to.
Yeah, the first one's absolutely terrible. Adarsh,
Well,
where you at,
didn't have
Adarsh? Let's see, Adarsh is here.
Listen, right, if you don't turn it down, I will be singing the entire lyrics from Loser by Beck.
What's Loser by Beck, dude? What's that? What's that?
You know, soy un perdedor. I'm a loser, baby.
Oh,
You
so
know it.
why don't you kill me? Yeah, exactly. Yeah. That first one I did kind of want. Anyways, okay, cool. Ooh, the
There's
other
2 of
trick
these here.
functions. I'm gonna do one of these because I gotta help out a lot of kids today. But I'll do one of them, Adarsh. I'll do one of them. Okay, let's see. You need help
Oh,
on 5.
You're doing
Excellent.
5.
Okay. Use the given trig value to find the other 5 trig functions of theta. I believe there's some requirements on this, though, Seth, right? Don't we have to know something else in order to figure this out? Exactly, Jeff. It is ambiguous.
Yeah, but then it's a not.
There are
Oh,
2
you got
possible
questions. You
quadrants.
got a chat question, so you have to take that one.
Yep, I saw that.
Oh.
I saw that. Well, let me bring my chat up so I can.
Hang on a minute, isn't this
Gotta
just a
pull that one out
calculated
before
job?
it goes away, because it will go up in chat too far and it'll low.
Here, I'll screenshot it. I can screenshot it, I think.
It's a 2-parter now, because it's been split.
Okay, whatever. I'll just dump the screenshot there. Okay. All right. Again, all right. So here's the issue, Adarsh. So tangent is equal to the opposite over the adjacent, which
Oh, there's the rest of it. Come on,
oh, that's
come on.
okay. I'll see it.
Writing.
Jabron, in the
is it?
future, use the website, please.
Yeah.
I know y'all can figure out how to take screenshots. So the issue is that 3 over 4 is the same thing as -3 over -4. That's why technically this can be in 2 different quadrants. So I could either have the opposite be 3 and the adjacent be 4 here, or I could have the opposite be -3 and the adjacent. Oh, sorry, no. the opposite be -3 and the adjacent be -4. These
You
are
know you just do
technically
2 cases and have
both
fun with it.
correct.
That's how this
I'm going to do
goes.
one of them. So the hypotenuse is 5. We understand that, right? This is a 3, 4, 5. Yeah. Anytime you see opposite and adjacent are 3 and 4, the hypotenuse is 5. Same thing would be 5, 12, 13. I forget the other ones, but something like that. Usually they'll have to say something here. So they will give you this question, and then they could say, for instance, cosine of theta is negative, or they would say cosine of theta is less than 0.
There, yeah.
Okay.
I'll take that.
If they
No
tell
way,
you
dude.
that, what's up? No way, dude. What?
This is GCSE level, so it's just what you see is what you get. This is
Yeah.
just a calculator job.
Well, no. The issue is that whether the other trig identities are positive or negative depends on what quadrant you're in, technically. So it's a little. Okay. Well, he's assuming everything's in quadrant 1. Okay. We'll assume everything's in quadrant 1. Cosine of theta is positive. If cosine is positive, cosine is adjacent over hypotenuse. And hypotenuse is always positive, so that means the adjacent is positive. So, yeah. So, yeah, if this is theta and your tangent is 3/4, opposite over adjacent, that means this is 5. If they're not nice numbers, you end up needing to use the Pythagorean theorem to figure this out. But yeah, once you have this, then you can figure everything
Jeff,
else.
no.
Dude,
Not
Jeff with
now.
the cinch and Kosh.
You done messed up, Aaron!
Get the fuck out of here, dude. Oh, what's up, Femvox? Oh my god.
Okay, so did you hear? Adash says a teacher wants it to be positive.
Cool.
The
All right, so
advantage
they
is-
want things in quadrant 1. That's totally cool. Yeah, in that case, sine is opposite over hypotenuse. That's 3/5. Cosine is adjacent over hypotenuse. That's 4/5. And you're done. If
Nope.
you want the other trig values, you just got to invert
trig.
them.
It's just
So-
them.
This is the weird one. Is that secant is the flip of cosine, and cosecant is the flip of sine.
The way
I
you
always
can
thought
remember
that.
there's an easy way to remember this.
How do you remember that?
Do not pair.
Do not what?
These do not pair up.
Yeah, well, okay, but how do you remember they don't pair up? You just remember they just don't pair up.
These don't pair up.
Yeah, okay. Anyways,
That's-
cosecant isn't with cosine. Cosecant's with sine, and that's going to be 5/3.
Same.
This
same
one's going to be
names
5/4, and then cotangent is going to be 4/3. Sorry, and then there's a theta everywhere. But yeah. Math on a Wednesday. Yeah, that's us, Fembox. Anyways, yes. Good job there. Adash.
Yes. Or do you want to do the other one that posted? Okay, so it must be on the
I don't see I am that
It is
ghost here,
in
unless I am that ghost is here.
I went at Endar at the bottom.
What's Endar saying?
If you run out of stuff and are in the
If
mood
you
for a
run out
little
of stuff into the-
possibility, here's
Okay.
here's another one.
If I'm feeling like in the mood, I'll do it. Yeah.
It's
I get a
also-
feeling I
it's
won't.
Also induction. It's also a proof by induction problem with probability.
Yo, what's up, Skeeg? I put the negative for the inverse. Yeah. Don't put the negatives. Yeah, just flip the signs. That's all you gotta do.
Because there's a run out
One
of
sec.
stuff
Let me
problem.
make sure the TikTok isn't getting mad at me. They do like some weird captcha thing at the 1 hour mark. I have to like drag a puzzle or something for it to like not like bop me. Let me see how that works. One sec. Oh no, we're still
The
good.
next step is I am that Ghosty with partial payments.
Is Ghosty here? I don't think I see
Maybe
Ghosty.
if he's not if he's not, give him a Discord message with the images of the puts and resolved.
I'm just gonna put a big heart face. There we go. Okay, so hopefully the TikTok live stays active for another hour. They got like some timeout thing, I guess, because they don't want people doing probably like go to sleep. What's up, Obi, dude? Oh, yo, raid from our boy Simplex. What's
And
up,
Don
Obi?
Ragnarok.
And Don. Don does raids. Don, what were you playing today? I saw you were playing a game somewhere. Something about like on an expedition. Do you bring something? Shout out to Obi.
I think,
Oh
well,
boy.
it's Minecraft Eds. I don't know what the name is.
Dun, dun, dun. Oh, why did we put a check mark next to Endars yet? We haven't done Endars yet.
Because it says if we have time. So it's.
Oh, okay. Put a question mark next to it.
Not
Put a
gonna have
question.
time for it.
How about a question mark?
We're not
I was
gonna
doing
have time.
Planet Crafter. Oh, that's cool. Planet Crafter? One sec, I want to check that game out real quick. Planet Crafter.
You know, that means we're using that's for next time. So
Oh, I know about this game. I think I know about this game. Oh, it's on Steam. Yes, yes. I think I've seen you play this game before. I definitely I recognize the style of it. Yeah, it's like a colonizing game. That's super cool. Nice. Okay.
I'm next.
Satisfactory and Satisfactory. I think that's the game I'm thinking of. Yeah, had a baby. Oh, and we got a screenshot in the help screenshots.
Okay.
From Jabron. Oh, Jabron, you use the screenshot function.
That's dope.
I'm so proud of you, Jabron. Jabron, I'm gonna do your question next, just because. I'm gonna. It's a different one.
It's part of it. It's only part of it.
Okay. Good job, Jabron. Was who?
Are we doing that one first then?
Let me just do Jabron's first, because I want to reward him for being a first-time person to actually use the help screenshots.
All right.
Yeah. Good job, Jabron. Yeah, happy face.
Physics-based.
It is physics-based, which makes me happy. I went to UCLA today to go get my keys to my office, and I tested out the lecture hall I'm teaching in next week, so it was pretty cool.
Nice. How was that?
It was cool. I mean, the administration's kind of disorganized because they couldn't give me my ID card because apparently I'm not officially hired until after the first day of my class, which I'm like, excuse me, but they were at least able to give me an office key. Although I will say it's a pretty sad looking office. Let me show you guys.
Oh shit, you're a professor now?
I'm a lecturer technically, but yeah, dude, where's my pictures? Dude, what? Dude, I took a picture of this place. I know I did. One sec. I'm gonna find.
I mean, you're a doctor though, right?
I am a doctor of physics. That is true. One sec.
Very impressive.
Oh, it didn't upload them yet. Upload them, you silly goose. I don't know why my stuff didn't upload. Can you upload, please? Okay, there you go. Now it has it. Okay. So yeah, this is yeah, let's load today. There you go. This is my office. This is going to be my office. This is the empty room. At least it's kind of clear, and there's not a bunch of random
your stuff on the wall, and we did.
I don't know whose this is. Yeah, space science. I don't know. Is this like Russian or something? I don't know, but yeah.
Nope.
That's the default.
French, Russian, and Spanish probably.
Oh, that's what it is. Okay.
Just put some of your stuff on it.
Oh, this was me going to the getting my Bruin card. I was going to get my ID card, but they apparently didn't have my ID card ready for me because I'm not hired there yet. Apparently, I don't know. And then I have a picture of the lecture hall. Who wants to load? Is this it? Yeah, here we go. This is the lecture hall.
Video.
You get a free photo of my feet for now. There you go. Yeah, so this is oh, it's I don't know why it's rotated, but this is it. Yeah. Giant ass lecture hall with 182 kids about to be in it.
Hey,
yeah. Look at all the monitors. I got like there's 3 of these things. 3 massive.
You gotta have that in a college.
Yeah, you do. So.
What college is this at?
On the back,
UCLA.
very top. Gotta.
UCLA. Endar says, I signed my contract on the second day of class. I wasn't even technically allowed to teach class the first day. Took another 2 weeks to get a campus email address. What a mess. Yup, it's basically like that. I think the only reason things are going smoother is that I was a grad student here 5 years ago. So I'm at least still in the system enough for like an email address and things. But I'm not for any other stuff, but whatever. Ukla. She big. My friend's brother's going to UCLA. Cool. Tell him to register for my class. Although it might be like a conflict of interest if like, I don't know if they're getting help on here and I'm also teaching it, but whatever. It's free.
Yeah, we did. So they're like, see him twice.
Yeah, see him twice. I think he's taking physics.
And what they can do is tell all the other 181 students about it.
Yeah, there you go. Yeah.
So that way your chat is invaded by college students rather than help students.
Yeah. Could be whoever. Yeah, we just got to stream more. All right, let's do your question, Jabron.
Yeah.
A child travels down a slide. The weight of the child is 250. I hate when they put the weight in newtons.
Is he in chat?
Yeah, Jabron's watching. He's on YouTube. The height of the slide is 7 meters. So I'm going to do this. I'm going to make this 7. The work done against friction as the child travels is 1300 joules. What is the change in the gravitational potential energy, and what is the final kinetic energy of the child? The child. The child, man. It's okay.
So this is that synergy equation again, then?
It's actually cool. This is work energy. It's actually a really interesting concept, because some people might freak out here and be like, I don't have the angle here. What am I gonna do, right? But it turns out I don't think you need it. I'm gonna explain why. Okay, so we have the force of friction, or sorry, the force of gravity pointing straight down, and that's gonna be 250 newtons. Okay. And then we have what's called the normal force. Pardon?
How is it 250 though?
Because we say the weight of the child is 250 newtons.
Well, it's
You-
force to gravity, mass
Yeah,
times
Yeah,
gravity.
usually they would give me the mass, and then I would have to say m times g is the force of gravity. But
Oh.
weight is technically also the force of gravity. So that's why we say 250. This is the normal force.
Well, it's a rotated normal force, so. it should make sense.
Yeah, but it always... Here's the cool thing. The reason why it's called normal is it's always perpendicular, normal, to the surface that it's on. This is always 90 degrees.
I know. I'm just saying there will be rotations going on.
Correct. Yeah, no, you're
That-
good. All right.
Yeah.
So I like to like break this up into components. We probably won't need it yet. I'm just going to show you how generally this thing is like set up. And then you have, because this is falling down, you have the force of friction pointing this direction.
Which I don't know.
Okay.
Oh, we don't. Ooh, we do care about friction.
There's actually a lot of stuff I don't know here. Because I know the work done against friction.
Is let me ask you this.
This is, so
Is
I think
this-
there's a typo here. I think this is the work done by friction, not against
Is it-
friction.
Is this the same? Is this using the formulas that we used last week? Yesterday, sorry.
Not quite. I mean, kind of.
Well,
Work equals force times distance. It is related.
No, I mean the
for
other,
sure.
the one for kinetic and potential energy. That you show.
Yeah, we will use those. You're right. We will.
You can't just go to that and we.
So here, let me move some things. I can move some things around because technically this thing starts up here. I kind of messed up. Dun, dun. Done by. Yeah, Jeff is right, and I'll explain why Jeff is right in a second here. Okay, we got to put this at the top. This is at the top.
He's traveling down a slide though, so.
Yeah, it's pretty cool why this works out the way it does. It has to do with work is defined as the amount of force that's in the same direction as the distance, or the amount of distance which is in the same direction as the force. That's what that's the mathematical interpretation of work is equal to F dot D. This is a dot product.
Oh.
Okay.
That
Which,
will take them.
do we remember dot product, Seth? Do you know what, oh, thank you, Endor. Do you remember what a dot product is? Dot product measures, yeah, thank you, sorry, it is this, F dot D, yeah. They're vectors. So it measures how much of this is in the same direction as this. And it turns out that that's going to equal to the magnitude of F times the magnitude of D times cosine theta, okay? Which is also the same thing as D times F cosine theta. Okay? And instead of all these weird like magnitude things, just you know, be nice. And you just write this. It's just FD cosine theta. Or it's also DF cosine theta. Where this, for instance, is the amount of distance, which is in the direction of the force. And this is the amount of force, which is in the direction of the distance.
Which should be the same.
Which should be the same. Yeah. Does that make sense, Gibran, where that comes from? Have you seen this before, for instance? Have you seen work?
Okay.
Work is equal to FD cosine theta. Okay.
Did you read Jeff's statement?
What did Jeff say? You could also derive the distance formula on the sphere. Jeff
baby.
loves spheres. Jeff is a big spherical lover. He loves his non-Euclidean geometry. Why does the child weigh in newtons? Good question. So, weight is technically a force. Anytime you see kilograms, that's technically a mass. Pounds, however, is a force. This is the weird thing. We tend to equate pounds and kilograms as the same thing. They're not. Because technically a kilogram on the moon is different. Sorry. A pound on the moon is different than a pound on Earth. A kilogram on the moon is the same as a kilogram on Earth in terms of what that is. But pounds is a force. Yeah, I think they use slugs for one of them or something. I think slugs is the mass unit or something. Okay. So, this child is falling down. And as he falls down, he's going to experience some things. So, first, he's going to have the force of gravity, which is pulling him down.
Is there also a force pulling him down?
Yeah, that's the force of gravity pulling him down. Gravity is the force pulling him down, and specifically, it's
two different directions. Yeah.
Good.
And multi-directional.
It's if this is theta, this is also theta, is what we say. It's specifically this amount of force.
And Jeff, I don't know.
Sliding. He is sliding. Yeah, he's sliding. Yeah. Part of my whatever. He's going down the incline. So, if I want to calculate the work done by gravity, I need to calculate the force of gravity times the distance times the cosine of the angle in between those two things. Okay. So, gravity, this force right here, has components in two different directions. Okay. It's got part of the gravitational force is like pulling it into the plane, and part of the gravitational force is pulling it down the incline. Okay. So if we want to talk about the distance of, this, I'll use a black arrow, and I'll say like this is like the distance. Okay. Then Black Arrow, new DC hero? No, that's Black Adam. Okay. Okay, force of gravity points straight down. That's going to be equal to mg, which is also equal to our 250 newtons. Okay. The distance it travels. Okay. Well, this is kind of interesting because I don't really know what this distance is, right? That's unknown. What I do know is this side of the triangle, okay? I know the opposite side of the triangle. So, if I wanted to figure out how much this was, right? We could use sine, and we could say that the sine of theta is equal to the opposite, which is 7, over the hypotenuse, which I'm going to call like the distance.
Yeah, sine theta equals 7 over d.
Good. Okay, cool.
Distance is 7 over sine theta.
Good. Okay. Now, so distance, good. We don't need it. I know we don't. I want to show like how it cancels though, because it's kind of cool how it does. Distance is 7 over sine theta
times cosine theta, which
Oh.
So
Yeah.
You got a tangent problem. It's about to become tangent.
No, I'm gonna show. Yeah, I'll show you. Yeah.
It's gonna be annoying.
It's actually kind of
like,
cool. Okay, so the distance would be
So
times
7 times.
7 over sine theta. Okay, and then we need the cosine. This is a different theta. This is
And
the
you know it's
angle
different.
in between.
Yeah. So isn't that theta is the 90 minus sine theta?
So yeah, watch what happens. So the angle in between gravity and distance.
Well, you don't need to. You don't necessarily need to talk about that.
So
Like,
watch this. This is cool. So let's remember that this is the distance. This is the gravity. So that angle in between those two is this. which, right, if we went all the way around, this would make a 90-degree angle. So this angle right here is 90 degrees minus theta. Or the other way we write this is pi over 2 minus theta, okay? So, inside here, I would use pi over 2 minus theta. So we get 250 times 7 over sine theta times the cosine of 90 minus theta, or pi over 2 minus theta.
I don't know. We don't know what 90 degrees is anymore.
Yeah, pi over 2, we don't, right?
It's
Yeah,
fine.
okay. Now here's the cool thing. Cosine of pi over 2 minus theta, this is an identity that you learn in trig. This is equal to the sine of theta. So, the cool thing is, you end up getting 250 times 7 all over the sine of theta times the sine of theta. These cancel. And it's just 250 times 7.
Is that what we have a value there though? Stop.
So, yeah, that number would also be a lot simpler to choose so what we did there is we took the amount of the force that was in the direction of the distance and we multiplied them together. That's what this whole like mess here was. We could have also said, okay, I'm just going to call the force this one, and I'm going to look at how much of the distance is in the same direction as the force. The force only points up and down. So all I care about is the amount of distance that it travels in the up and down. And that ends up being 7. It travels up, down 7. The force of gravity is pointing straight down. So then you can literally just do 250 times 7. That's the little hack that you learn. That's a lot easier to solve this question rather than doing all this mess. Yeah, this just sucks.
It's for the same reason it's a interesting physics thing that I tend to know. I can switch all the signs if I want to.
Yeah, all the
all positive, negative.
dude, physics is notorious for just like getting minus signs wrong all the time. We're just always flipping minus signs wherever. Okay, so the work done by gravity, by gravity is equal to 7 times 250, which, sorry, what is that? That's 1750.
Yeah.
Okay, cool. And then
It says 1300 joules.
we say that by friction is equal to 1300, okay? And that's like a negative 1300 because friction is doing negative work. So friction has a force pointing this direction, but the thing is falling this direction. So the angle between those two is 180. And so the cosine of 180 is -1. So you end up doing your work ends up being negative. That's just something you just have to kind of look at this problem and know. Since friction points the opposite direction that the thing is moving, the work is negative. Okay.
Hey, Dr. Gold, I'm gonna pop out, but I enjoy watching your streams, man. I'm gonna go work on these with a buddy, but keep up the good work. And also, dude,
when are they due? When's your stuff due?
oh, it's due tomorrow. I'm gonna work on it with a buddy, bro. You don't have to worry about doing them or anything.
Should I
Okay,
check them
cool.
off then, Swaz, or you
Okay.
or-
Yeah, go for it, man.
Well,
but
if you-
yeah,
if you-
good luck
if you
with
have-
your
Make sure.
Yeah, say
good luck
again,
with
Swaz.
your new lecturing job at
Oh.
UCLA, man.
Appreciate that, dude. Thank you, man. Yeah,
Sure.
if you have like
Look
some
interesting,
stuff
but-
that like really doesn't make sense, just DM me. I'll help
Yeah,
you later tonight.
All right, sounds good, man. Appreciate it.
All right, peace. Oh, one sec. I gotta fix. the
TikTok's down.
TikTok. You know, it did. God damn it, I missed it, and now it had me raid somebody else. Yeah, one sec. Let me fix that. Let me fix it.
Did you forget to do some things in the?
You have to. Well, at least I know now that in order for me to look like I'm active, I have to. There's like some weird captcha I have to hit at the 1 hour mark exactly. There we go. Okay, now that's fixed.
Oh, sorry. Do you not know the rules about Chink Talk?
Chink Talk. Yeah. What are the rules?
you have to randomly say Xi Jinping long live.
Yeah. Long live Winnie the Pooh.
Yeah.
He's like, no,
Actually,
not
that will actually get you permanently banned if you say that.
Yeah, I can't say that. I can't say that. One sec. Let me refresh this one then. Here, let me turn it off. Let me see if it detected it yet. No, that's Vanessa. That's not. One second. Let me stop that.
Big titty foxlots. Sorry.
Artist. Yeah, there we go. I think it'll. Okay, good. It found it. Okay, cool. All right. Because yeah, the chat has like so much random stuff on it. Here, let me trigger some. Thank you, Obi. Yeah, there. That one's working now. And then let me trigger some fake messages. There we go. Awesome.
Oh, that's a lot of stuff.
Well, because it had all the other TikTok messages in there. Okay.
And
all right.
Facebook. They're hiding Facebook messages.
Yeah, you could have. We could be streaming on Facebook, but I don't think any students use Facebook. Okay. Sure. Okay. Changing gravitational potential energy and the final kinetic energy. Okay. The change in the gravitational potential energy, that is the work done by gravity. So you would say that the change in delta, I say UE. This is what I say for like gravitational potential.
Yeah.
That's equal to negative 1750 joules. Yeah.
Why is it negative though? How do we flip it?
It's actually interesting. It comes from this. So F is equal to negative grad U. So we say that the force of something is equal to the negative derivative of the change of the potential energy. So do you remember what Nabla is, Seth, in like math land?
Nope.
Nabla is the same thing as just ddx basically in one dimension. Nabla in vector calculus can mean like ddx, ddy, and so forth and so forth. It's called the gradient operator, and it's a way to like take derivatives, but you can do, for instance, like this is called like divergence, this is called curl, and then this is called grad, and these are three different things. This gets you a vector, this gets you a vector, this gets you a scalar. But for the simple, not crazy stuff here. If we're doing things in one dimension, this is just ddx, is what we say. And so if I move this over to this side, right, f dx is equal to negative du, and then let's integrate both sides. This is the equation for work. The integral of the force times the distance, and then this gets you negative delta u, basically. It's negative u final minus u initial.
Which is
right? So that's why work is the negative change in the potential. So the change of the potential is the negative of the work. Pretty cool thing. All right.
Kind of one thing about our district. We do physics before calculus.
That's wrong. You should really do calculus before physics.
That's why I don't recognize any of that.
Yeah. Well, no, you won't see this until you get to vector calculus, Seth. Like you won't see that till much higher level calculus.
I wish we would have done the calculus first. Is doing that for AVETs?
Yeah.
Acceleration, velocity.
Yes. Acceleration, velocity, position.
A lot easier than just doing all that.
I agree.
Kinematics.
Yeah, I agree. It's kind of whack.
It'd be a lot nicer than kinematics.
Calculus was created for physics. Like, calculus was a tool that Newton invented because he wanted to do more physics. That's why I always joke with the math people. I'm like, you do realize that like calculus was invented for physics? Like,
that's dope.
Like, who's your daddy? Like, your stuff was created for us. All math is pure. Jeff.
Well,
anyways,
we flip the order. We do calculus after physics.
Yeah, I would do calculus before. I would do calculus before physics. Do not sully it with your lousy physics or approximations. Okay. Anyways, final kinetic energy of the child. This is another thing called the work energy theorem. So by work energy, we're gonna say that the change in kinetic energy is equal to the net work done on an object. So the net amount of work done on an object will be the change in the kinetic energy. So in this situation, we had two things doing work. We had gravity doing work on the object as it slid down, and we also had friction doing work on the object as it tried to like keep it up. And so what you do is you just add these two together. So W net is equal to 1750 minus 1300, which is going to give you 450 joules as your change in kinetic energy. I think Jeff said this earlier at the beginning of the whole question.
Yeah.
But yeah. So yeah, that's how you do that one. Jabron, did that make a little bit of sense to you, doing that? It's a cool question. Nice. Okay, cool. Nice.
So here's the order I was thinking about
That way, in case we have problems remaining, I could always help them out.
Yeah, and I appreciate that. Yeah, you can help them out.
So
in
here's
case.
I'm gonna recommend this order. So let's do the one from
What's up, Pen?
Anadoski first. I don't know what I'm doing with that. And then from Equity, the physics and chemistry ones.
Yeah, can you ping Equity, see if he's around?
We're gonna do the other. I am the Dosti and give him a
Shout out to Penn Center.
Photos of
Penn Center in the chat. What's up, dude? Statics. This is, I don't know if this is called statics though, because this thing is moving down. So it's dynamics. But we call this mechanics is really what we call it. Or like kinematics. It's like intro kinematics. Which, funny enough, this is what I'm teaching starting next week. Yeah. Correct. Yeah. So. Yeah.
The first step. So, I am that Dosti's one, but you can always share that one into.
Sensation's voice sounds different because that's Seth. It's Seth, not Sensation. Dun, dun. Chill with some statics. Yeah. Let's see.
If I'm the Dosti's not here,
which one you say we do? Well, where's Equity? Where's Equity? Where's my boy Equity?
I don't know. Don't worry about that one right now.
All right, I'm gonna.
It's elevated at 620. It's back a little bit.
Akamis says, "Hey, can you solve my homework? I can help you do your homework if you want." Yeah, we can definitely help you.
It's not our homework.
Yeah, I won't do your homework, but I'll help you do your homework. But yeah, if you want to like submit your screenshot to that website down there, then we can help you with it.
That's what I say. That's what I say to people that said no one's help. You want me to do it? Don't care. You need help? I'll be glad to.
Where's Bob Ross's?
I'd start with the English, to be quite honest with you.
What would the English be? Oh, help them with
help them with their English. You know,
I would be.
Every sentence begins with a capital letter. Twat.
Yeah. Wow! Congrats, Penn Center, new job. Oh, you can't find where on Discord? It's in like help screenshots.
Yeah, help screenshots. We can't pin you.
What job did you get, Penn? What'd you get? I start my new job next week. Double booms. Yeah, wait, do we have the boom? Do we have the boom one? Let me see, is it this one? No, not that one. Where's the boom guy? So I'm gonna get him for you. No. No. Wait, maybe it's this one? No, that's Lil Yachty. I'm gonna find him for you. Well, I mean that guy's cool too. No.
Yes!
Well, we do like that too.
Oh, we're
there we go.
Sorry to hear about your brother
Here,
that
Penn.
passed away. He gets 5 big booms.
We're gonna use some booms. Boom. Boom. Boom.
So, here's what we're looking at from Dosti.
But what's your new job, Penn? You didn't tell us what your new job is. I want to know what your new job is. It's an annotator job for data science. Oh, very cool, dude. Love those gigs we get, those side gigs, right? Yeah. Oh, special relativity. I'm about to hate myself. Dipping your toe into the data science game. That's a good market these days. I will say, lots of nice investors too.
So looking up at I am the Dosti, we have.
Akamis just submitted one. Here, let's do Akamis's because
where's that one at?
I just posted it. Well, he just posted it in the website.
Don't worry about it then.
Exactly, stepping stone job, Penn. Exactly. Yeah, that's honestly what I'm taking this UCLA job as like a stepping stone. Yeah, you're getting your feet into the market. People will see it on your resume, and then they'll be like, oh, maybe we can hire him for more stuff. And then maybe you'll work for a tech startup, and you'll be infinite billions of dollars money land. Okay, let's do this one.
Placed at the torus of a square with a side length of 1 centimeter.
A charge of -6 is
This is an
located
E
in
and
the top
M
left.
question.
6 is at the top.
Here, let's make our square. Let me make my square. This is a classic E and M question. Okay, so -6 is at the top left. I'm gonna make that blue. Top left is -6. Okay, and this is gonna be -6. I love how they just said -6. Like, -6 what? Is this coulombs? That's a really big charge. 6 is at the top right. My goal is to eventually work for Daddy Elon at X. Praise Daddy Elon, dude.
Well, it's not zeros. I know. Well, not.
Oh, okay. This is cool. Put another 6 here. Yeah, dude. You're gonna start going to cool AI conferences and stuff. You know. Maybe you can come down to our side of the, Silicon Beach, San Francisco. Oh, there's Equity. What's up, Equity?
Yep.
There he is. You won the Pascal contest in your school? Oh, hell yeah, dude. Nice. I mean, it kind of makes sense you would win the Pascal contest because you keep asking all the Pascal contest questions on this stream.
Yeah, absolutely.
And you do really well with them. Sorry to hear about your brother. Have 5 big booms. How'd he pass Demolition X? That's dope.
That's dope.
That does deserve a that's dope, dude. Congrats.
Yeah, I'll put that one as
Shantrix.
a time, but soon.
You got 130 out of 150. Does that mean you didn't get question 25 right? Uh-oh. Okay. All right.
No,
let's
it
see
also
this
mean that he answered some and not zero, and because I answered some.
one. Oh, you
zero,
get points, right, for not answering, and then you get less points if you answer
for
wrong.
Not answering, no
Such a
points
weird-
if you get it wrong, and then points if you get it right.
Yeah, that's such a weird one. Okay. Force on a particle. We're going to call this particle 1 and particle 2. You only really need to solve for these, because
Jeff
once you
has a
solve for
question.
these by symmetry, it's all easy.
Is this
This is a DFQ. What's DFQ? Differential equation? No. It actually just comes from this. So the force, let's say the force on a particle. Well,
again, Jeff? No, he said no.
no, it's not differential equations. Yeah. It's the sum of the forces is what it is. Okay, so if we look at, so let's just say, looking
So it is.
at 1, okay, we have to do the sum of the forces, which is going to be F2 on 1 plus F, here, let's call this 3, let's call this 4. F3 on 1 plus F4 on 1. So each one of these charges is going to exert some sort of force on this first charge. And what we learn is that for charges, the force between two charges, so let's say F2 on 1 is equal to K Q1 Q2 all over R squared. So Q1, Q2 are the charges, and then R squared is the radius. I think they are all towards the center of the square. Well, let's see. Okay, so let's look, for instance.
We don't know that.
Wait, do we know the dimensions of this square? Oh, the dimensions are 1, right? This is 1 centimeter.
Nope, you don't. You know what you got. 1 centimeter by 1 centimeter square. Yeah, you
That's
know
okay.
that.
Okay, this is 1 centimeter. This is 1 centimeter. So another thing I'm gonna. Well, okay, we'll get to it. Let's just do the first one. Okay. So F2 on 1, which is gonna be the force between these two forces, which is entirely in the x direction. We have to separate them by components, so we'll get into that. This is going to be equal to K, and then it's going to be Q1 and Q2, so that's going to be minus 6, comma 6, all over the radius squared. Do you answer any questions? I do. Yes, submit your screenshots. Go do it. Yes, and the important thing here is that opposites attract, same stuff repels. So in this case right here, the force that the first charge feels from the second is to the right. It's going to feel it. This one's going to feel like it's getting pushed this way. So actually, when we're doing this E&M stuff, I tend to just not even write what the charges are, like the plus and minus, until the end. And then you got to use intuition just to see which way it goes. So this is going to end up equaling 36k. And then because it's a positive and a negative, this thing is going to get pulled this way. And so we're going to say that force is positive, and we're going to say in the x direction. Okay. Let's do F4 on 1. That's going to be the same thing. K, 6 times 6 over 1 squared, because we're doing these two charges, which is going to equal 36k. And that is going to be in the positive y direction, because these charges are, or sorry, negative y direction. Sorry, negative y direction. Because this one wants to get pulled down towards the positive charge, right? This is positive 6. Okay. So we figured out what these two things are doing to this. The last one that's kind of tricky is between these two. So we're going to say F3 on 1. So that's going to be, again, K, 6, 6. But now the distance in between these things, the R, is not going to be 1.
Square root of 2.
Good. It's going to be the square root of 2. So in order to figure out that, you have to do a little bit of geometry here, Pythagorean theorem, whatever.
Or
so that,
an knowledge of 1 square root of 2 ratio.
Or you could know that too. You could. So, but that's r squared. Square root of 2 squared, which is just 2. So this ends up equaling 18k. Now, the direction of this force is kind of funny because, first of all, these are the same charges, so they're going to push each other away. This one's going to like try to fly away from this one, okay? So we know this one is going to feel a force which is pulling it to like the top left, okay? So what I want to do is I want to break that force down actually into components. I want to say that it has a y component and an x component. And here we know that the y component is going to be positive and the x component is going to be negative because it's going to the left and it's going up. Since this is a square, I know that this angle is going to be 45 degrees, which means if this force is F, this amount here will be F sine 45 degrees, and this side will be F cosine of 5 degrees. Yeah, we'll see. Now, the sine and cosine of 45 degrees is square root of 2 over 2. So what we're going to end up saying is this is going to be 18 times the square root of 2 over 2 in the y-hat direction, and then it's going to be 18 times square root of 2 over 2 in the negative x direction. So we're going to say negative in the x direction. Okay. All right. Now, and we can cancel this so that this is 9, right? And then this is 9, right? Okay. Now what we do is we figure out the total force.
These are plus 9 squared root of 2 and then 36 minus 9.
So total force means we're just going to add all the things up, and I need to add them by components. So I need to do x with x, and then I need to do y with y. So x with x is going to be 36 minus 9 square root of 2. And then that's all k in the x-hat direction. And then it's going to be negative 36 plus 9 square root of 2 k in the y-hat direction. And then so there you go.
Magnitude of the force, of the total force on each part.
Dude, oh, they want the magnitude? Well, they want the magnitude in the direction. Okay, so this is kind of annoying.
So what they want you to do is put in a right triangle and enjoy the solving of that.
Yeah, okay, fine. All right, so magnitude. That's going to equal whatever the x component is squared plus the y component squared, and then you're just going to square root them. That comes from a triangle.
That's a nightmare one.
That is messy, dude. I really don't like that.
Yeah, you do though, because you wanted to do this problem. So
I did want to do this problem. One sec, my calculator's the wrong
blood.
color. I gotta fix my calculator. Can't be using no silver calculator. Absolutely not. There we go. Gold calculator. Okay. So I'm going to do 36 minus 9 square root of 2.
You put your squaring function.
Well, and then I'm going to square it. So I'm going to do this, right? And then I'm going to square it. And then I'm going to multiply it by 2. And then I'm going to square root it. Uh-oh. What
And you
did it
fail.
look like?
Because it does beep.
I have to do second answer. There you go. Okay, cool. So the magnitude is 32.9. Well, and then there's a K in there. 32.9 K.
Yeah. What direction?
Okay. And then that's like newtons. And then
Yeah.
the direction, right. Well, we know it's to the top. Well, actually, let's look at this. Sorry. 36 minus 9 square root of 2 is positive. Okay.
And the other one is negative.
The other one's negative. So our overall direction,
Is southwest.
yes, it's
Oh.
this way positive. Okay, let me see what Fembox is saying. Fembox might be right. We'll see. It's southeast, yeah. And then it's just this. Yeah. So, okay, and now here's the cool thing is, I already know what the angle is because these are the opposites of each other, right? So we already know this angle is just going to be 45 degrees because the sides are the same.
So you can
If
point
you really
9
wanted to do it,
at 45 degrees.
yeah, if you wanted to do it, you could do the arc tangent of the y versus the x, but I'm pretty sure you just get the same thing. Right, because this one
not
is
if
this.
You run an answer though. Yeah.
Yeah. And then what if I do this, right? If I do second insert. Yeah, let's look at the symmetry argument. Okay. Yeah, they're the same. It's 45 degrees. So you could say 45 degrees southeast. Or I think they say like east of south. There's some weird order to how they say it. I think it's south of east.
X of y. X of y. Yeah.
Oh, it's east of south then, right?
It's X. You always say X and y. Yeah. It's X and y and.
Well, I guess it works either way. Oh, ESE with SE? Yeah. Okay. Let me see the argument that Fembox said. Fembox says you don't really need components here because of the symmetry of the arrangement. It's easier to actually sum the other two forces on that charge because the sum will lie on the same line of action. Yes. So he makes a good point here that if instead I define my axis of things moving to already be this, then what I can see is that these two will cancel out, right? The amount that this thing gets pulled in this direction by this one will cancel the amount it gets pulled in this direction by this one. So all you're really doing is seeing how much this gets pulled this way by this. And it's going to be twice because both of these charges are doing that. Yeah. I think the way though, however your teacher usually wants you to do this. They want you to go through and do all these steps. It's unfortunate, but it's good practice because things won't always be this nice.
Let's just wait 18 more minutes to do 3 more.
Yeah. Okay, so let's see. So yeah, that's it. And then just do a similar thing for the other ones. I think what you'll find is that this force is the exact same for this one. It's just in an opposite direction. Well, actually, no. So if this one was pulling in. So this one is also going to be pulling in this way. And then for this one, I think it's the same thing, Fem, right? I think they all do this. They all have the same magnitude of the force, and their directions all point inwards. You can eventually see that by symmetry.
Ready for the next one then?
Cool. All right, good.
Grab the periodic table out. Grab your periodic table out, and I'm gonna give you some notes, some things.
Okay.
What's in now? It's from Equity, but I'm gonna give it to you with words so it's easier.
Okay. Equity, what's up?
Have the picture of it and have the and I'm gonna give you.
Do I need like? I just need the numbers, right? Nothing like crazy, right?
No, you need. I'll be asking you in a second what you need. List the elements that I'm gonna give you in a minute in order of decreasing atomic radius.
Oh, I like that. Okay.
I'll
One
give you
second.
the, I'll give you the name in a second.
Let me grab this.
Have periodic table and have 1, 2, 3, 4, and 5 ready.
Okay. What are they?
5. In
So
order
D-
to decrease atomic radius.
Decreasing atomic radius?
Yes. The easiest way to write this is 1 through 5, where increasing on top, decreasing on bottom. No, sorry, increasing on top, increasing on bottom.
Okay.
In given.
So like
Okay,
this way.
First up, lithium. Lithium. You can have that. You can find the numbers if you need to.
Yeah, lithium.
Huh?
What else?
Neon.
Neon.
Potassium. NO. I do know that one.
NO?
Yeah, nitrogen. Yeah.
Oh, just N. Or nitrous oxide.
Yeah. And then phosphorus.
P. Okay, cool.
See what I
Neon is bigger.
Here.
Is neon bigger? I don't know. Well, I don't know about that. So usually, atomic radius goes increasing this way. So it's increasing down a column, which I think is down a family, and then it's decreasing going this way. It does have a full shell, but I don't think the full shell matters as much as the number of protons and electrons in that shell. So, okay. The biggest thing is going to be whatever's furthest down. So let's look at what we got. I'm just making stuff up. It's okay.
So lithium, if you want to circle them, it might be
Yeah, let's circle them. So lithium's here. Neon is here.
Is K. K is 19.
Oh, N is here. K is
19.
here.
And then P is way on the bottom. I think it's on the lower.
No, P's here.
sections.
P's on 15.
Oh shit. Okay.
No. Yeah, interesting, Femvox. The radius actually decreases as we go to the right. And I'll explain why in a bit here. So let's look at, for instance, we already know the biggest thing is the thing that's the furthest down, because that means it has the highest N level for its valence shell. This case is N equals 4. This is going to be the biggest.
And any.
It's going to be K, and then it's going to be P. Okay, this is where things get tricky, which is the LIN and NE. Okay, so the explanation for this is, okay, let's look at lithium, for instance. Lithium has an atomic number of 3, which means it has 3 protons in the center. And then in its outermost shell, which is the N equals 2 shell, it's going to have 1 electron, right? It has 1 electron in the outer N equals 2 shell. Yes. Well, it's 1s2 2s. It's 1s2 2s1. And then let's look at nitrogen, for instance. So nitrogen has what is that? 7 electrons. So nitrogen has 7 protons. And it has in its outermost shell 1, 2, 3, 4, 5 electrons in the N equals 2. They are SPDF. Yeah. No, it's okay. If I wanted to label out nitrogen, it would be 1s2, 2s2, 2p3. That's what nitrogen would be. The shells do matter. Oh, well, so the orbitals don't matter. The orbitals don't matter. The shells do. Yeah, they're called orbitals. Yeah, I know. It's the terminology is annoying. Okay, whatever. All right, and then we have helium. Yeah, I'm looking at the outermost valence shell. No, you're good. No, and believe me, it is very complicated sometimes. It's confusing. So, okay. Helium has 8 in its valence shell. And it has was at 10 protons. Okay. So, what's up, Omega Kent? Yes, dude. Omega Kent's our chem guy. Yeah.
Helium has 1. I knew that.
Sorry, not helium. Sorry. Neon. Sorry. Yeah. I was looking at the right thing. I wrote the wrong one. I do. Thank you. Okay. Each one of these atoms technically has the highest valence shell at n equals 2. So we would think they're all the same size. But what happens... What?
Read Pensiner's comment.
It took me a while to warm up, but I'm finally coming out of my valence shell. Yeah, okay. So what happens is, as we start going across a row in the periodic table, we start adding protons, and we start adding electrons that are in that outermost shell. And now what happens is, let's say, right, this has 1 electron here. This has 5. 2, 3, 4, 5. And then this one has 8. Some might be quick to say, to be like, hey, wait a minute, this has more shit. It must be bigger, right? Turns out, no. Because what happens is, this has more, what I call, like, grabbers. It has more Coulomb attraction. It has more points for the protons in here to grab the electrons on the outside and bring that shell in. So they all have n equals 2, but this only has, like, 1, like, grabby point. Whereas, as you go across, you start getting more grabby points. This is the most iconic thing that ever crossed my TikTok. Thank God. You're welcome, dude. So, yeah. And this is very related to the last question we just did, right? Which was someone else, I think, on YouTube asked this. This was Coulomb attraction. So, when you have charges that are different, in this case, right, protons and electrons, they attract each other. And if you have more protons to attract more electrons, that shell they are in gets smaller. Is there a formula for the atomic radius based on shell electrons? There's not. It's all relative, is what it is. Yeah, yeah, exactly, fam. Yeah. Yeah, this is a very commonly misunderstood thing, atomic radius. But it's related to everything, though. What's up, Seth?
When I first did this in chemistry, it was a couple years ago. This was something I had trouble getting.
Yeah.
I made the same.
But this means everything, because even for, like, ionization energy, like first ionization energy, all that stuff is related to this. It's related to, like, how far out your outermost valence shell is.
Okay. You ready for another?
It's partially a step function. You are right. Yeah. Do you want to see the here? Let me show them what it looks like. It's actually pretty cool. Atomic radius graph. It looks weird. Yeah, it's like this. I wish do I have it on the periodic table? Do they do it on the periodic? I want it on the periodic table.
That right there.
This is kind of what I want. Yeah, right. Yeah, this is cool.
I don't know. Yeah.
Yeah. So you can see, right, as you go from left to right, it goes down, but then as you go down, it goes up because you're increasing more and more and more. Kent is super right. It is, yeah, it's not a fact, it's a trend, because sometimes it rises, sometimes it lowers, but as a whole, the trend should hold. Yeah, because what you end up getting is this.
That diagram what I liked. Yeah.
Yeah, this diagram is cool. Where is it? Yeah. So you can see, so when they go lithium, sodium, potassium, rubidium, cesium, this is going down to the next N level. So every time you go down, you spike up, and then it drops off. But you can see sometimes, right? Especially here, this is where some weird shit happens. Because you start getting, like, the d orbitals involved as well. What's with the little bumpy parts? The little bumpy parts, I think, is because now you're dealing with some different shells. So when you're just dealing with s orbitals and p orbitals, things are fine, but then the d orbitals start doing some weird shit. And then there's also some stuff where, for instance, you'll get to a certain point here, and rather than fill electrons in here, it would rather fill them somewhere else. Like, it'll start borrowing electrons. I think copper is the example for this one. I think copper in its ground state would rather steal an electron from here in order to fill up this shell versus leaving this one almost filled and having this one filled. Again, the periodic table is like trying to be an approximation of how life works, but it has so many exceptions. Yeah, most transition metals and most decisively in the lanthanides and actinides. Lanthanide contraction. Yeah, okay. I didn't know that was a term.
Now, the next one, the way I'm going to say this, so the next one here is 15 parts.
15 parts?
But it's not at 15 parts. It says there's a chart to fill out.
Okay.
So.
You want me to find the chart?
There's going to be a compound, and then Lewis structure, 3D structure, and shape name for that.
Oh, okay. I'll do a couple of these. I'm not going to do all these.
5 compounds.
Lanthanide contractions? Does that when a transition metal gives birth? It's funny.
So if you want to draw this out, you can or chart it.
Let me take your phrase.
So,
do you know why?
You might need a product table because I don't know what these are.
Yeah.
So what's each one? So it's AS.
Let me do the hardest ones. Well,
how about this? Do one of the name what they are, the element wise, or
yeah. Let me do this one maybe. Let me do CF2H2.
How about do the easiest one then do the hardest? Because I don't know what this. I do not. Either I don't know.
The easiest one is probably ASCL3 is what I would say.
That is
I guess because it's first.
Hardest one is the
First thing you need is a Lewis structure. So I like to figure out what the valence electrons are on anything.
And the Lewis structure is what exactly?
That's the thing with the dots.
I thought I might remember it.
So wait, arsenic AS is here. So that's 1, 2, 3, 4, 5. So that's 5 valence electrons on arsenic, 7 on chlorine, and you have 3 of these. You have 1 of these. So that's going to be 5 plus 21, which is equal to 26 electrons, which in my mind, I always divide by this by 2, and that means I get 13 sticks, 13 bars to play with. So I'm going to connect this, AS, and then we know it needs to at least connect with 3 of the sticks to CL. And then let's just try to fill the CLs. 1, 2, 3, 4, 5, 6.
And wants 7, so it wants to have equality.
Each one wants to have 4 sticks on it. So this has 4. Here, actually, let me change the colors. Let me change the colors of things.
Yeah, I remember this now.
It's cool.
You have to put it over the chart, though.
Exactly. There we go. There you go.
You want to copy that over?
Wait, is there a charge on it? No. It's just it's ASCL3.
Fill out and do. Down to completion.
Well, let's see. So this is 4, 12. No, 4, 8, 12. Okay, so we have 1 left.
Yep.
So that means that's here, and that just becomes a lone pair.
And lone pair because there's not enough.
Well, no, because I needed arsenic to have 4 bars, and I'm only allowed to use 13 total bars. And that's why it's 3, 6, 9, 10, 11, 12, 13.
And then why lone bar? Why the lone pair?
So anytime a bar doesn't connect to something, we just write it as 2 dots as a lone pair. I just like the.
Why is okay.
We could. They're typically ignored in a Lewis dot structure because this is implied. But I guess we could write them. Yeah, we can. That's fine.
And then you have to move that to the chart as well.
Yeah. Well, I'm just gonna say it's here. I'm not moving it. No moving feet.
And then the rest of these is doing the chart. The rest of these doing the chart, so you don't have to do it yet over here.
Yeah. Okay. So 3D structure.
And that's not it though. That's 12 on that.
Sorry. Yeah. Whatever. I missed 2. So there's a difference. I don't know why they call it 3D structure because there's a difference between molecular geometry and electronic geometry. Called a Lewis dot structure, not a Lewis line structure. Thanks, Endar. Yeah, one of these is like molecular, and one of these is like electron. I forget which one's which, but
which one do we need? Which one do we need then?
Well, we need both, but I forget. Okay, once it's
which one's the one they want for the Watson though?
Oh, you're suppressed on Discord? Oh, you want to come up?
What?
There you
Need to
go.
move someone over?
That's all right. Most time, there you go. What's up, Kent?
Hello, hello.
What's going on, dog? Oh, we got a chemistry expert up in his house.
Not as much as an expert, but no, just a bit, a little. Most time they ask for molecular geometry, not for electronic geometry, and well, there are far more molecular geometries than electronic geometries.
Yeah.
What's your question?
And then, well, so I'm trying to find the chart. There's some chart that I always use. I think it's this. No, it's not this one. Oh, it's called like basic geometry. Yeah, wait. This is the chart I want. I want this chart. I just want it in a higher resolution, please. One sec. Can I submit GED practice questions? Yeah, you totally can, Fairy. Just use that link. Wait, no, this is not it. Wait, what? Where'd my image go? I would like this image, please. There we go. This is it. It's going to be really bad resolution, but okay. Yeah, okay. So they call it like the geometry... Dude, this is weird. Look at this, Kent. They say geometry of electron pairs, geometry of atoms. I don't know why they say that. Dude, where's just the basic thing, man? What is it? I think it's molecular geometry is what I'm looking for. Okay, this is it. This is the image I want. Okay, this is the one I want. Screw this one. Go away. Go away. There we go. All right. If we look at this one, this has electron geometry and molecular geometry. I don't like how they group this. This is pretty bad, but whatever.
So what do we care about from this?
Well, we want to care with the amount of bonds and the amount of lone pairs. This right here has 3 bonds and 1 lone pair. Okay, so I look here. Well, actually, sorry, it has 4. Sorry, it's 4 bonding groups. 4 bonding groups. Okay. Yeah. Okay. So 4 bonding groups, so you count bonds and lone pairs. So that's 1, 2, 3, 4. So I'm gonna look here for 4, and I want 1 lone pair. So 4 and 1 is here. So that's gonna have an electron geometry of trigonal bipyramidal. Again, I don't know which one they want here. Equity, you gotta tell me which one that is. But I think it's like trigonal. I see. I think they want you. I think they want you to just draw this. I think they just want you to draw it.
Draw it and name it.
Oh, okay.
Draw it
fine.
and name it.
I see.
It mentioned that.
Oh, sorry, my bad. Okay. So they want this.
Draw.
And then is it like this? Do you know they do the weird like the triangle, right? They do like this. I don't think he has to do this for his class. Oh wait, it's ACL3, sorry.
Yeah.
Wait, this one is wrong. Oh, I don't like this diagram at all. Sorry, this
It's not the trigonometric pyramid.
It's this one. It's tetrahedral.
That's it. Tetrahedral in electronic.
Yeah. Oh man, I lost it. Man, why are these people calling me? Stop calling me people. Okay.
Yeah, 3 bonding groups, 1 lone pair.
Yeah.
Which is what we...
Yeah, okay. CL, 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 and then this is a lone pair. It is 3-1, yeah. It has to do with the table they use. I gotta look at the table. Because it's called steric number, right? Isn't it called steric number, Kent?
Yep,
Yeah.
steric number.
Yeah, steric... Fuck this, I don't like this one. This chart's confusing me. This is usually what we use. Steric number refers to how many bonds and lone pairs you have. And then you go in this chart with like how many lone pairs you have. And that'll change what the shape is.
3-1.
So 3-1 is so this is not 3-1. This is 4-1. It's 4 steric centers. 3 of them are bonds, 1 of them is a lone pair. So it's this one. It's 4-1 really, is what it is. This number refers to the number of like things that are attached to your central atom. Yeah.
including the number of either lone pairs or single electrons.
Cool. Exactly. Yeah. And right, double bonds don't count as 2 though, right? So even if one of these bonds was a double bond, so I think SF2 is a double bond one. Let's do SF2 for a second, right? So SF2.
So you're not gonna finish that one up then?
Oh, that one is done. I mean, that one's done. And then we just say it's tetrahedral. Or sorry, no, it's trigonal pyramidal. Sorry, it's trigonal pyramidal. But let me skip down. Let me skip down to SF2 because SF2 I think is an interesting one. So sulfur has 1, 2, 3, 4, 5, 6. Okay, so sulfur has 6 valence electrons. Fluorine has 7 times 2. So this is 6 and 14, which is 20, and then divide by 2. That's 10 bars to work with. Okay. So now we have S here. We're going to use at least one line each to bond to the Fs.
And would it be true if it had an odd number, you'd have to separate, you'd have to deal with a lone pair?
It'll never be odd. This number will almost never be odd for a high school student. If it's odd, you screwed up.
Oh, if it's odd, it's going to be doing something weird.
You just
So,
can't.
fluorine,
I don't know if I've ever seen in my academic career of teaching
Like
chemistry
sulfur,
an odd
Like
number
we
of
did.
electrons.
1 sulfur, 1 fluorine, not 2.
Yeah. Oh yeah. Well, so that's always like a good hint. Like you messed up if this number ends up being odd.
I mean, what if we had 1 sulfur, 1 fluorine? So it'd be a 13.
You wouldn't.
It'd be-
Yeah. Well, what would happen there, Seth, is you would get something like SF minus. So this minus would mean that there's an additional electron that enters the situation. I believe. Or it might be like...
There are some interesting molecules that have an odd number of electrons. For instance, the pandemic known chlorine dioxide has
Chlorine
an
dioxide?
odd number of electrons. Yeah. And
ClO2?
Yeah, that's it. Also, the nitrogen oxides, NO and NO2, very important because of the smog and, well, the performance of engines. Both have an odd number of electrons. And most time with this substance, you always start bonding the atoms with an even number of electrons.
Yes.
And, well, even number of electrons always.
Now, isn't NO2 usually NO2 minus?
That's the nitrate ion.
Nitrate, right? NO2.
Nitrate. But there is a molecule, but then there are different substances.
Mm-hmm. I see. That's the nitrite ion is what we're saying. Yes.
The negative charge, the neutral, and there is another one with positive charge, the neutronium cation.
What's NO2 plus? That's not nitrate? Nitrate's NO3, right? Or is it like per night? Actually, no. I'm thinking about NO3. Sorry.
Nitrates are NO3.
NO3.
Negative.
Yeah.
We are
I see. They call it nitronium. Wow.
That's it.
I did see the message, Sensation. You're good. Yes. So, yeah. Kent brings up a good point. A lot of times, though, if you see NO2 as something that you need to figure out the Lewis structure of, they're going to call it NO2 minus, which means this is 5. This is 6 times 2. So you get 12 and 5 is 17. And then you have an extra electron, which makes this equal to 18.
I thought N was a 6 or something.
No, N is 5, I believe. Am I wrong? I'm pretty sure N is 5. I'm pretty sure.
Yeah, you have to be careful about taking always the number of electrons in valence shell, not the whole atomic number.
Exactly. Yeah. This one's 5. 1, 2, 3, 4, 5. And then oxygen is 6. Yeah. Yeah. Anyways.
I knew the chlorine one was odd.
Yeah, chlorine is 7. Yeah. But that's usually why you have like 3 of them and like something else, or like 4. Okay, so if we've used 2 lines here, but we still have 10, let's try to like fill it out, right? Let's try to do this. So that's 1, 2, 3, 4, 5, 6, 7, 8. So I guess you could do this. 9, 10? That's correct, yeah? No, he's good. I got him, Sensation. You're good.
Yeah, that's it.
Oh, so that is it. Okay. I was wondering... Yeah, okay, that works out. I was hoping there would be a double bond in that one, but I guess there's not.
And will it ever not finish off?
So this would end up being... this is 4 and 2. So you have 4 steric places and 2 lone pairs. So that would make it bent. Yeah, so you say this one is
Will it
bent.
ever not finish?
Will it ever... Sorry, not finish? What do you mean not finish?
Like having 6 instead of 8. Not have a full...
Oh.
Finish diagram off.
Yeah. I mean, you can totally... So you can actually have there be too many. So that's called an expanded octet. You can have some that have too many, quote-unquote, like, electrons connected to it. But almost always, you'll have at least 4. I'm trying to think of some that only have, like, 3. Maybe, like... I'm trying to think what...
Boron compounds.
Boron, right, okay.
That's it. Boron, aluminum, the atoms from that group used to have up to 6 electrons, but sometimes they can always have... sometimes they can have 8 or even more, but
yeah,
many times just 6.
Yeah, like Xenon. Xenon can have a bunch on it, right? Xenon can stack. Yeah, let's
let's do 2 more today. There's
Okay.
2 more types for Metrity. They're math
Okay.
types, but they're 2 different types. So
Okay, I'll look at it. Yeah. So Xenon, for instance, this one can have 1, 2, 3, 4, 5, 6, 7. 7 steric. Can you really be sure how many electrons are actually there? It's a probability, technically. Nothing is absolute. We don't know everything absolute.
So there's 2 more.
Okay,
so
2 more questions
it's
today.
40 p.m. Don't do both. We just want the one of them. They're the same type.
All right, I'll just do one of them because I do want to go to the
Then,
gym at some
then we
point.
do another one. Then we do one that has then the word problem as well. So that's a different type. That's has greater than less than stuff in it. Once we get to that type,
volume.
it's 2 different types.
Okay. All right, whatever. Let's do this one.
I don't know what the person wants though. For graphing these or for solving what we're doing.
I think this one's just solving.
Which one are you looking at?
This one right here.
That's the other type. We want the easier one first. That's that has inequalities. There's one without and there's one with inequalities. G of x equals 8x minus 10x squared minus 17x plus 10. That's a non-inequality type.
Okay.
That one is for later. That's second type.
Yeah, maybe I'll save that one for another day. I'll do this one because then I do really want to I want to go to the gym. Gym's gonna close. I'll do this one though, and then we'll end it. Okay, volume of a block of ice is modeled by this. Well, I don't know. Equity. Which one do you want help with? I assume equity just wants help with whatever, so that's okay. I know equity. Equity's chill. What thickness of wings can be carved from a block of ice with a volume of this? Okay, so they're saying V is equal to this. So we're going to say...
No.
2532. Yeah,
it
right?
Doesn't equal that.
What's up? What's wrong with this?
We should have less than that.
Oh, yeah, whatever. I know what you're talking about, but okay.
It's an inequality, not an equality. What thickness of wing?
Well, this is I'm going to solve for the maximum. I'm going to solve for the maximum. Right? And then it could obviously be 0, right?
Is we're not doing calculus probably.
Okay. Can you just help me start to solve this one and then do the inequality? Okay, fine. All right. To start to solve this,
because we can't do calculus on this.
Okay, I'm going to move this over. And I'm going to see if anything is divisible here. Do we got anything divisible?
That'd be a no.
Is 2532 divided by 9?
Wait. If it's this way, 3 we're good. 3's the only taste we have.
Yeah, 844.
Yes, 3's are.
Okay.
3's work, 9's do not.
All right, we can pull 3 out. So that's going to be 3x cubed plus 20x squared plus...
No, 3.
Sorry, what?
81. That's the number we love. Oh, 83. Sheesh.
83. It's 83.
81's the nice number.
Minus 844.
Yeah.
This is a huge pain in the ass.
No, it's not.
What do you mean?
3
it's
times
not?
844 factors.
I'm not writing out all the factors of that. And that only works for quadratic.
Like
This is a cubic. This is a
No
cubic.
just allowed, so.
This is a cubic.
No
You have
just
to guess
allowed.
the factor.
Hard way.
Yeah. So what you would need to do here, equity is called the rational root theorem. And I would technically have to check all the factors of 844 over all the factors of 3. 844
Yeah,
has more than a
Compare
few
844
factors. It's got so many factors.
We-
Oh wait,
844
211 is prime?
Yeah.
Is it? Oh, that's cool,
Yeah.
Kent. I didn't know
Yeah,
that.
and
Oh, okay. All right. Okay, 4. Okay.
It's like they're not going to give you evil problems. That would be mean.
I thought this was really evil.
I can make it evil if you only do one number
Okay.
change. It's
Yeah. Oh, but also we have to
That's
do
how- that's
divided
how
by
it is.
3 and stuff.
evil.
Okay. What I generally like to do here is just guess and just plug in. So I'm gonna guess 4. I'm gonna say, hey, does 4 work? Let's try 4. So 3
Minus
times
4
4
in the-
cubed is 64, plus 20 times 4 squared
There's an
is
easier
320,
There's an easier way
plus
than that.
304 to 320,
There's one
333.
way, there's another way than that would actually help them. That would actually help the problem go faster. Take x minus 4 and divide that mess by it.
Yeah, we're gonna get to that. Don't worry, no, we're gonna get
Well,
to
if we
that.
do that first, and we know it is because it tells you if it is or not. If it is a remainder, we're already farther in than we need to. be.
Yeah. But
We're doing
what you
the
should do,
first
you shouldn't do long division until you know
I don't
that
want
it's
to
a
do long
0.
division. I want to do net division. I wanna do
Whatever,
easier.
one of those divisions. Okay. What did you have to divide by 3? I divided every term here, equity, by 3. And then I pulled that 3 out and I just killed it here. That's what I did.
Is what I'm saying is, if we do net division first and it works, it's done.
Yeah, but you don't want to do synthetic division and then it's not. And then you're
If not, we
fucked.
do it again. That's the part. That's the fun part. Not we get to do it again. Unless you want to do it the
We
easier
have we
way,
have
the
different
fast
opinions
way.
over what is fun.
We'll punch 4 in the machine. See what I did.
All right, one sec. Is my TikTok still working? Let me make sure. TikTok hasn't got mad at me for streaming over an hour. These people, dude. I swear.
Probably has.
It probably has. Oh, yeah. It says I have to drag it. I have 1 minute and 15 seconds to do it. There we go. Wait. Try again, dude. What?
Don't
There we
fail.
go.
You have to do it.
Okay, we're good. We're good. Okay. Yeah. So apparently,
other
at the 58-minute mark, I need to go back to TikTok and tell them that I'm still a person. So.
The other way is doing a tabular table function, putting the 4 and see if it's 0.
Okay, we're gonna assume that 4 is a factor. So I'm gonna divide this whole thing by x minus 4. All right. So you can do synthetic or you can do long division. Which way do you like, equity? Do you like synthetic? Oh, what's up, OP Black? I haven't seen you forever. Do you want synthetic or long? Both work. Oh, you know how to do the rest? Okay, cool.
We're done.
Cool. Yeah. Just divide by it, factor it out, and you got it. Okay, nice.
That's dope.
And also, that's how you do the
Exactly, the remainder theorem. Kent was right there with pointing out that 211 was prime. How do you know that, Kent? How do you know that 211 is prime? You just built different?
Well, the easiest way is it's not 3s, it's not 7s,
Okay.
it's not 4, it's not 2s, 3s, 5s, or 7s.
Ooh, the Erathrosthenes method? I haven't heard of that one.
You want me to show you the easiest way? You want me to show you thing? It won't take that long.
Well,
give me a table
no.
with 1 to 100, and I can give you, you'll light it.
What do you want me to give
You'll
you?
light. No, I'm gonna show you. I'll show you what he means. I'm gonna show you how easy it is to prove.
Okay, what do you want me to
With an
do?
easier example.
What do you want to do?
So give me a table 1 through 100, please.
You want me to write out 1 through 100?
Well, a table wouldn't be. You can use a table of a picture if you need to.
Okay.
Just need a table 1 through 100. You'll like what happens. You'll like this. I've learned it once, and it's like this is a neat thing.
You want this?
Yeah, that was the list. That's what we want. That's gonna have our factors
I had
all
it up to
listed.
1,000. He said. Okay. All right. What's up? What am I doing
Okay.
with this?
And then let's do 2s. Okay, cross out every factor of 2 for me,
Okay.
because that's the first prime. So all
Okay.
factors of 2, cross those out.
Okay.
Let's go to 3s. 3's prime, so let's factor all the factors of 3. Discard those.
I'm getting rid of these.
Nope. Nope.
No, no,
nope,
no.
That's not right. Factors of 3.
Oh.
All factors of 3. They have not crossed out already. They're found in very easy places.
Are they?
Yep. 21. You
Oh.
missed 21. It's not. Nope. Wrong.
Isn't 45 a factor of 3?
35 is not. 35 is the wrong one.
You're right.
You can't have 2 next to each other. 21 and 33. What's at the pattern?
Is it turning into a pattern?
Yes. You see it? It's a
Mr.
shape.
Krabs. Do I see it yet? Oh, I see it, Mr. Krabs.
21 to 3, and you see that those diamond shapes. Cross out all the factors. You missed. You jumped.
Oh,
75 is which one did you miss here? 45 should be 54, and then 63.
Yeah, you could do the prime factorization, Ken. You're right too.
51 is one. You missed 50. Yeah, 51 is out. 48 where do you got? 57. Yep. 63 is out. That's the one we missed. That's what I was annoyed about. 63 is a missed one.
Right. 59.
59. Yep. And then 81. 93. 87 is not.
Oh, 87
is not. And then 96. Yep. And 90. There you go. And then do 5. So 5 is also a prime number.
Oh, I could just get rid of all these.
5 can go away.
Yeah.
Okay, now do 7. So
Okay.
easier. You're gonna realize something. We're going to get stopped in a second. Oh wait, 87. Oh sheesh, 87 is sheesh. I've added a number wrong. 7s, please. So 7 is 49.
7, 14, 21, 28.
14 done. 21's done. All the numbers up to
49, 63.
That's it.
Okay.
You're done. Why did that happen? Because you've already done the factors of it. Okay.
Oh, okay.
Try 11. You know what's gonna happen? Nothing. You're done. You found all the prime numbers. Other than 77, because you missed 77.
Oh, there we go.
Everything else must be prime.
Oh, because all of these already got crossed out. Oh, okay.
A fifth of the number is all you have to. Yeah, a tenth of it. Yeah.
Is
you
30
found the
wrong?
Oh,
No. 30 is 30 gets marked out for sure.
30's already marked out by the 10s.
Yeah, sorry.
You
I
marked it
was
out to the 5s.
marking and yeah, you're right. Okay.
You've done 2s. You marked them out differently.
It's a
than I did.
checkerboard. That's pretty cool. Okay.
That's the easiest way to do it. This is and this also works. Yep. That's.
Or you can just like memorize
whatever
it.
you're talking about.
All right, Equity, let's see. So
I can stop as soon as I hit 1/5.
subtract these over. You get negative 2x cubed minus 8x squared plus 12x plus 16. What's up, bro? What's up, boss?
Why am I -2?
Divide by negative 2.
Well, that's also going to cause a flip to happen.
Mm-hmm.
But don't forget to flip. Whoop. Nope. Yep, there. And then find the numbers. And root
6x squared? Sorry, did I get something wrong with the 6x squared?
Let's
I
look at
did.
it. Yes, you did.
No, I did.
6
sorry.
minus 12 is -6 divided by 2.
Negative 8. I don't know why I said that. Sorry.
So we should have
you.
a 3. Yep. And then
Thank you,
the
Joseph.
next step, root theorem solve. And then weird at the end of it.
I don't think the 1s work. Do the 2s work? 8 plus 6 minus 12 minus 8? No. 2 would be 12 minus 12 minus 8. Oh, yeah, the 2s work.
So
Wow, who just got me? Who was that? Oh, Sam. What's up, Sam? Yucky, yo, what's up? I hope you're doing well.
Right.
Thanks for the help a while ago. Yo, you're more than welcome, dude. We love giving help to you guys. Yeah. What's up?
And then there's one, and then at the end of that one, because it's an inequality, there's weirdness at the end of that one.
Yes. Let's get to it. 1 sec.
Play at the end. So you might want to solve that one out just to show, because it's gonna be weird. Because the end is gonna have some interestings that we have to deal with.
All right. So 2 works. We check the 2 works, right?
So
I can do. Well, here I can do this one, right? So I can.
Yeah.
So 2, 1, 3, -6, -8.
It's 8 laid out. Yeah. 1, 2, 5, 10, 4. Yeah.
Cool.
8, 0, and there's our 0. So
Nice.
X.
So this is x minus 2 x squared plus 5x plus 4.
Yeah.
Oh, then this is easy. This is cake, dude. This is x plus 1, x plus 4. Okay, cool.
X plus what there?
1 and 4, right?
That's a 1?
Sorry, it looks like a 1.
It's how you wrote it. No, I did. And then solve, but remember the rule.
Yeah. So now you gotta draw these in a number line, right? So, and you gotta find out in between, right? So at 2, you have a solution.
Make you to play 0 somehow, so you know it's
-1, you have a solution. Oh, sorry. These are open circles. These are open circles because it's not equal to.
correct. And then -4.
2, 3, 4, and then -4.
And then you also have, and then also if you would put 0 above, just so you know where 0 is.
Yes,
you're using how you're doing it. 0 above, because 0 is not friendly with this.
Oh, okay.
So it would not be in the way. Okay, so is it true above? Is it true above 2?
So yeah, so now you gotta pick values. So I always I pick numbers. So I'm gonna pick like -5.
You know that is 3 don't work though.
Yeah, let's check 3. We can check 3. So if I check 3, that's positive, positive, positive. It's greater than 0, right? Cool.
Yeah, positive. Yep. And then
So this one's good.
How about
Is 0 work? Right? 0.
Yeah,
so that's positive, positive, negative. Nope.
that's an additive. So additive instantly has
So
issues,
negative doesn't
so
work.
That's not happening.
That's a no
How
no.
about it?
-2 is so that's gonna be negative and a negative, which is positive times a positive. So this is true.
Fine.
So then this one's not. It's got to be this.
It's Twatson for you. College.
Where'd you go to college? I went to UT for undergrad. I went to UCLA for my PhD.
And then does negative 5.8 work?
-5. So that's negative, 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 which is gonna be negative. So this does not.
So we have our rule. So now
Cool.
we just take this.
So yeah, dude, some cool person, some Indian person showed me some
Yeah,
really
Indar,
dope
yes.
video for this.
And Indar has a rule for you as well.
It passes through all the roots, all the zeros. Multiplicity of
Supposed to be
each root
odd.
is odd,
Good.
correct? Yeah. So if you wanted to kind of like draw what this looks like, I think it's like this. Right?
Yeah, it's supposed to be that. It's supposed
This
to
is
do that because it's qubit.
Oh, what am I doing when I say positive, negative? Okay, let me show you. So I'm just looking at what each one of these things are. So for instance, if I check -2, -2 minus -2 is -4. So I'm just say, cool, that's a negative.
Because we know that a negative times a negative is a positive.
-2 plus 1
Negative
is
positive,
-1.
So
So
we
that's
only care,
also a negative.
and it's parity.
And then this
on
is a
which side.
positive. -1 plus 4 is 3. That's a positive. So I'm saying negative times negative, right? Seth was right. That's a positive. Positive times a positive is a positive, which
Negative
we're
times
greater than 0.
Negative times a positive is a negative.
Yeah.
So if there are an even amount of negatives, it must be positive.
Yeah.
And if there's an odd amount of negatives, it must be negative.
Yeah.
Rules of parity.
Parity. And that's what it looks like. Cool. Good job, Equity.
There is a geometry version and a graphical version.
There's what?
I think that's it.
I think it's it.
Unless you want to deal with induction theorem.
I'll do that next time, Endar. I want to go to the gym. I got to teach another student chemistry at 8:30.
Get this.
Oh,
Face. Okay, we're dead.
all right, we're cool. Awesome. Thanks everyone for coming around. Thanks everyone for coming to office hours today. Had a lot of fun working with you guys. Appreciate all the questions. Appreciate all the help. Have a great team of support that shows up. You guys in the chat. You guys on the stage. Appreciate all the help, Seth. You as well. Putting the questions in. That's great. Sensation, comedic relief. And yeah, y'all are great. Appreciate all you guys. Anyways, that's our last streak. Sorry, that's our last stream of the week. We'll start them again.
Yeah,
Thanks a lot. Yeah, thanks Ken. I appreciate your
Before we questions before we leave. Do we have anybody on Friday?
We do not have anyone on Friday. I'm getting ready for my UCLA course.
And Saturday, because it's your recess streams.
Yeah, we might have. No, I got to get ready for this UCLA course.
Okay.
I'm pretty screwed.
Have fun. When do you start UCLA?
On Monday, so
Have fun with that.
I hopefully will stream on Monday, and that will be my first day of class.
When you come on Monday, be ready to tell us how the first day was.
Oh, I will. I'll definitely tell you guys how it went. But yeah, if you guys ever want to figure out when else we are streaming, there's a website here. Just go to calendar.actual.education. You can see who else is streaming.
And
I think
streams on Saturday with E to the 2 iPod.
yeah, E to the 2 iPod is doing a math stream at 9 o'clock tomorrow on Saturday.
Noon Eastern time.
Yeah. Thanks, Zigzag. I appreciate it. Yeah. So okay, we're gonna go raid another person.
Let me see if any math streamers on my radar. Probably not at this time.
Yeah, if you see anyone, just let me know. I'm just gonna see who I got.
I'm saying probably not on this time because it's.
Who am I following? Who are we gonna raid today?
Wednesday, so.
Oh, Moo Hoodles was always cool. She's cool.
Let me see. Before you leave, let me see here.
Are we syllabusing first day or are we covering physics? Oh, it's interesting. Yeah, he brings up a good point. I am going to do a little bit of physics, but my lectures are only 50 minutes, so I'm going to do Q&A for the syllabus, and then I'm going to start going into units. So I'm going to try to teach the students how to do units conversion.
And that would be a no. Not surprising.
Yeah. Tangent is opposite of adjacent. You are right. Okay. Oh, Sage is on. Oh, go say hi to Sage. Let's go say hi to Sage. We're gonna go raid Sage. Sage is cool. She's a big part of the Knowledge Fellowship. So, all right, cool. Thank you everyone for coming around. I hope you have a great rest of your week. Have an awesome rest of your Wednesday. Fun stuff. We will see you again on Monday. Peace out.